Okay, video number 183. The day is Tuesday. It is 5:50 a.m. Okay, so we're going to pick up where we left off, and we're going to tie up some loose ends because we felt a little shot of adrenaline, so we might as well kind of keep on keeping on, right? So before we go, let's open up Torch browser, and we want to just get our chat window thingy ready because in case anyone kind of messages us or whatever the heck, we want to be ready. So that's not what I want. I'm not certain that I want Torch to open in the last window I had open before I closed it. I mean, that could be bad for reasons. Well, actually, I don't use Torch for that. I use Chrome for that. But you get the idea. That could be a problem. What if there's some type of confidential information on the screen besides not safe for work stuff, right? There could be confidential information on the screen. Anyway, so we're on number 3, and Uifrags is what we're doing, and so let's just do done. Okay, so Uifrags 183, game engine stuff. Okay, cool. So we got that up and ready. So yeah, let's just stub this in here. So we have this Uifrags, and the idea is that this is going to be kind of like UI code that is, it's basically like very high level fragment shader code. But it's lower level than any of the editor fragment shaders, right? Because the individual editor fragment shaders may need to reach into Uifrags to render user interface code. And also, this is called Uifrags because what we're going to do is we're going to make like Uifrags.PAINT5D. Right, Uifrags dot whatever, right? So we're going to name these shaders. We're going to make different shader codes based on, right? It's going to be a collection. It's going to be a collection. So I'm not sure exactly how this is going to work. But the first thought is let's stub in Uifrags. So we're thinking Uifrags. .d, so the data file, data here, goes in this file, right? So the data goes in this file, so uifrags.d._, and then we'll make another file, new file, and this file is going to be functions, right? So functions go in this file, right? So functions go in this file, and okay, so we've stubbed that in, and then let's get some boilerplate. So we're thinking right off the bat that there shouldn't be any type of data that we need to initialize. Everything should be statically configured with some types of defines. I don't really see any reason that we would need any initialization code for this. So if we don't think that we need initialization code, let's err on the side of not having an initializer. So we're going to do gssp. That's not quite it, is it? Paste AAC 2020 boilerplate. Right, that'll tell us what it's supposed to be. NSSBP paste. NSSBP paste. It's a very obscure like acronym. It's like, why did I choose that? But okay, functions go in this file. Let's just remove that commentary because now we have this boilerplate that usually goes at the top. And within here, we're going to just change the names, right? So this will be lowercase Uifrags. And then this is also, like, we're going to go and we'll replace all the lowercase stuff first. And then after we've replaced the lowercase stuff, we will replace the uppercase stuff, right? So bam, and then this is public, so Uifrags. Okay. And then bam. Okay. Okay, so now that we have this, we're going to also, the data, data goes in this file, you know, if any, right? Okay, so then within here, are we ready to kind of stub this in? Yeah, I think we're ready. Let's also not forget, because we do forget this quite often, we forget that we have this thing called silence. And if we look at where we're putting things, where we're inserting things, we have this game cam, then we have PAINT5D, and then Uifrags is where we want to put it, right? So right after game cam, if we even have code for that in here, because we may have forgotten to insert this. So yeah, game cam, cool. Game cam and PAINT5D. So right in between there is where we want to make our insertion point, and this is going to be Uifrags. So UI fragment shaders. So frags because it's plural. So this is the struct definition. So that means we also want to go down here, duplicate that, call this Uifrags, and the logging by default will be on until we want to turn it off later. Okay. So silence is taken care of, Uifrags is stubbed in to the best of our abilities, we think. And so now the next part is this kind of very tedious process, right? So we want to look at libchan. We also want to look at fmacros. So if we scroll down, or maybe scroll up because we don't know our alphabetical order. Scroll up. Oh yeah, so here is fmacros top and bottom. We want to open that as well. And then let's just open those first. Okay, and then let's also open the functions file. So here's this function file. It's already right there. And this one's open. So let's just do this one first. It doesn't really matter what order we edit this in. We just have to get them done, right? So here's the game cam. Here's the PAINT5D, right? So we can go bam. Change game cam to Uifrags, and it's going to have an init none. And 52, 53, 54, right? Okay, that also reminds me that that means, let's change these numbers here. Let's get this running correctly. Right, so we're going to make this Uifrags, fragment shaders for different user interfaces, right? So this will be a 52 now. This is going to be 52. UI fragment shaders, right? UI fragment shaders, UI fragment shaders, something like that, and then 52, 53, and 54, right? So our new highest library chain index is 54. So up here we see this 53. That's going to change to a 54. Okay, so now that we have that, the next thing we're going to do is go over here, bam, and then we're going to change this to Uifrags. Okay, so that's good, and nothing else needs to change. It was just that. So let's go and look at libchan top, I guess. So in libchan, we have to make another macro, right? So these macros are basically very straightforward. Libchan 54 is 54, right? And so this number right here needs to match, right? The max libchan macro we have is going to be set here, libchan max. Okay. So now let's go find 51. So if we go scroll all the way down to 51, so this is getting huge. So system number 51, and we just want to say, we just want to take this, right? We're going to go boom, game cam, and then we want to go over here, PAINT5D. Ooh. Yeah, it's between game cam and PAINT5D. Okay, we're good. And this one doesn't have any fancy cruft in it or pattern breaking code in it. So we can just copy paste this and change this to Uifrags. And then we can just say, oh, this is 52 and 53 and 54 is the last one, right? PAINT5D fragment shader code. Okay, cool. And so now we just got to scroll down to the function section. So this is the function section. So it's the exact same list, but we're including the function files. There we go. There's that stuff. So we're just going to copy this, and we're going to paste this. Once we have it, column select everything that says game cam, and just call it Uifrags. So you might notice that, right, all my variables are exactly 7 letters. Well, 7 letters or 3 letters is usually what I stick to. And that's so that everything kind of just works very nicely with column selection. And it also just makes it very easy. It makes the patterns in the code just dead obvious. And I just like the ability to recognize patterns in the code, right? Like if you can, the goal is that somebody who knows absolutely nothing about my code base should be able to scan through the code visually and find mistakes in the code because some type of obvious pattern has been broken, right? I keep on using right as an accent, like a punctuation mark. I feel like maybe I need to stop that. It's better than using all the time, so I guess maybe I should be okay with it. Okay, so here's where we have this game can. So we got if, end if, end if. So we'll take that, we'll paste this in here, and then between game cam and PAINT5D is Uifrags. Okay, so now we're going to go in here, and it's the same exact kind of deal. It's just like, it's a redundancy, right? So we have the same, it's the same thing basically said in another way, because the more redundancy we have, the less likely we're going to make a mistake. Or not the less likely we're going to make a mistake, but the more likely that if we do make a mistake, we will be able to catch it. Because there's really no way to write any unit tests for what we're doing. And so we need a lot of redundancy, because otherwise we could be editing this and we make a mistake, and then just, if everything gets assembled in the incorrect order, if things get assembled not in the order that we think they're in, well, this is my whole dependency management, right? So if things aren't included in the order that I think they're included in, we're just going to have a very bad day. A very bad day, possibly a very bad week. So we absolutely do not want to screw this up. So that looks good. Okay, let's close that. So F macros. In F macros, we've added Uifrags, and that does not have any initialization code. But before we look at that, we should probably look at these numbers. So 51, anything around 51 we might need to look at. So this is a 52, that's after that. So PAINT5D is probably now 53. Yes, it is. So this needs to be 53, this needs to be 53 over here. Save that. Okay. So now if we look at this thingy-mabobber, it is init nuns. And in between the game cam, we don't know if that's going to be here, but game cam, and we don't have PAINT5D, we have P5D10GL. PAINT5D probably has an initializer, that's why it's not here. So Uifrags is going to go here in the list, right? So we want to keep kind of the same order, but this is the list of the things that have initializer code. And now that we've highlighted those two things, we know the correct insertion point. So rather than rebuilding this whole list, which we have the code to pragmatically rebuild this, but it'll still be a pain. In my experience from doing this many times, this list has gotten long enough to where it makes sense to just manually make this entry this time. And then in the future, the thing is we have to be very careful, right? Like if we screw up any one of these things, we'll just get very wild, erratic behaviors. So Uifrags, and that's there. So let's look at that for a second. Is that all colored correctly? Yeah, that looks good. Okay. Is there anything else in here? I think that's the only thing we had to do there. There's also this list that is not guaranteed to be updated. We're not going to touch it. It's just wasting our time. I'm sick of updating that list. Okay, so now this is just cleanup code. So game cam and PAINT5D. So here's game cam. And here's PAINT5D. And you'll notice that in here, we've interlaced the init nuns and the inits. Just because it actually just makes it a lot easier to look at everything and get like get a high level overview of what's going on, right? We see all the systems in their solve dependency graph order, and then we know what systems need some type of fancy initialization code. So most of these systems don't need any fancy initialization, right? Because most of them are init nuns, but some of them are initial inits. So in here, duplicate this line. In the middle of this, Uifrags has no initialization code. And that's fine. That's the way it should be. Okay, cool. I'm a little bit paranoid, though. Did we actually do the main function? Did we actually do this? I know we did it first, and so maybe it's like... I don't feel like I did it, though. Oh, no, there it is. Uifrags, init none, 52. 52, yep. And it's also in the Control F help. Do not extract this. Control F help. It's already there? Okay, cool. So we're ready to give that a shot, and we don't expect any behavior change in the code. That's not what I wanted. We don't expect any behavior change in the code. We just want to see, hey... We want to see, hey, is this code going to compile? Is it going to compile? Is it going to run at runtime? Is it not going to blow up in our face, right? Because we're not actually... We didn't add any functionality, right? We stubbed in some boilerplate, and then we integrated this new subsystem into its correct slot, and not what I was expecting. Out of order AAC 2020 includes... So we probably just got this thing wrong. So where is this coming from? File included from libchan bottom. Oh, libchan bot. Okay. So let's go look at that. So in libchan bot. Okay. And if we look at this, that tells me that I know a common mistake I make in here. So it says out of order. Yeah, so I know exactly what mistake I made. Well, I don't know for sure, but I make this mistake quite often. Yeah, right here. I make this mistake so often that I knew immediately. Right here. Well, not immediately, but you get the idea, right? So this thing that says game cam needs to be Uifrags. Right? So the idea is we have a lot of redundancy, so that the idea is, like, right, we don't have any way to write unit tests for this. Therefore, we need a lot of redundancies to catch our mistakes. And actually, a unit test, all a unit test is a redundancy to help give you a better statistical probability that there are no errors in your mission-critical code. And so why do I say mission-critical code? Because I can't say there's no errors in your code, right? Because you just removed the... If you add unit test code, you lower the probability of there being errors in the code that's being tested, but the unit test code itself has the same probability of errors that the original code had before you wrote tests for that, right? So you're kind of what is the euphemism? Like you're passing the buck on, but that's okay because you just want to reduce the probability of errors being in your mission critical code. So it's okay if there's bugs in your test code, as long as that test code has helped reduce the probability of bugs in your main code, right? Like, you're never going to get rid of all the bugs in your code. Now, you could argue that the test code and the production code have some type of dependency, like have a cyclical dependency between each other, and so they check each other. you could argue that. So you could argue, but as far, and you could argue that to some degree. So you could say that, let's say that the probability of errors in your code without test is, the probability in your mission critical code of errors without unit test is 100%, right? And then let's say that when you add tests, the probability of errors in your mission critical code drops to like 10%, and then the probability of errors in your test code, rather than being 100%, is like, 90% or like 50% or something, right? You could argue something like that. But I like to be conservative with my paranoia. I like to kind of be conservative with it, right? So I'd rather err on the side of caution. So, so to think of it as writing test code helps lower the probability of errors in your mission critical code, but now the test code itself has the same probability of error that your untested code had previously before you wrote the test, right? So it's the whole who watches the watchers kind of a problem. Anyways, that worked. That worked, didn't it? I got kind of distracted, so I'm going to compile it one more time, and then we're going to think about how the heck are we going to draw this? How are we going to draw this user interface? So the first thing is we need some type of code that's going to position the user interface rectangle for us. So, so this is the a memory view, a memory debug view to make sure that those glyphs have been loaded into the correct memory slots, or not the correct memory slots, but the texture that is storing the glyphs for the user interface. It's exactly where I want it in memory, and this kind of crazy image here kind of is verifying that for us. So this is the PAINT5D editor, and so what we want to do is you can kind of see that when we resize the screen, this editor, the main, this is the main viewport rectangle that has a gray in it, and what we want to do is just, for now, I think all we want to do is just put like a UI list, like right on the side here. Like keep it kind of dead simple. And since most people are not going to be working on like a vertical monitor, right? So we might as well just make this for, and also I'm presenting this on a horizontal monitor. So it'd be easiest just to create some type of rectangle that's of it'll be a fixed width, and then it'll be 100% height, so the height will be matched to whatever this rectangle's height is, right? And when we do this, like when we're like resizing the screen, whatever code is responsible for resizing the screen, we need to find that code, and we need to add some hooks to edit the user interface rectangle that's going to go right here, and then add some code to render that user interface rectangle. We'll start off with just rendering the user interface rectangle as some type of solid color to verify that it's in the correct spot, that it's the correct dimensions, and then we'll work on it from there. And if we're lucky, we'll have kind of a rudimentary user interface made before we go to bed. If we're lucky. I don't know if we're going to be that lucky. But let's keep motivated, because we don't really have a good bit rate all the time, and we have a good bit rate right now. So let's keep with that. All right, let's milk that good bit rate that we rarely get these days. Okay, so first thing is, how are we going to look through our project and find where the resize code happens? Well, the first thing we can do is we can take an eagle-eye view of all the systems, right? So we can look at this main C11 file, right? So if we open up the main C11 file, we're greeted with this big master list, right? And this master list could kind of help us. I don't know why do I have this thing here? I don't know why. This master list could kind of help us figure out what we're looking for. So we want something that's for like window resizing, right? So this is GinaWin, right? And this is graphics in window, but we know we're not going to use callbacks. We know we're not using callbacks. And instead of using callbacks, callbacks, we used something different. We used like it wasn't iKeybox. It was the CPU uniforms, right? This so there's a list of uniforms. So CPU side uniforms. So this CPU side uniforms should actually contain a thing called iResolution, right? So whenever iResolution is updated is probably dependent on window resizing somehow. And I don't know how that happens, but my guess is that somewhere in here... oh, we have a loop tick. Okay, so rather than using event-based code with, like, callbacks or something, we kept it dead simple. We just, like, every game loop, we're probably looking at it and saying, hey, has the window size changed? And if it has changed, then, hey, update some stuff, right? So CPU uniforms loop tick. And, oh, hey, look, here's the iResolution width, iResolution height, as some crazy macro stuff. Cool. Now, the question is, where do we change this, though? So we see that we have this, and we update that, and this is on the CPU side only. Okay, well, where does it happen on the GPU side? I have no clue. So first of all, here's what we're going to do. So we are going to find this, but we don't know when we're going to find it. So what I would like to do is in my documentation, right, we have this master stream of consciousness, right? So like 6,000 lines of just stream of consciousness, right? So we're just going to say, hey, you know, where to find window resize hooks, right? Or where to find window resize callbacks. So we don't actually use callbacks, so I don't know where to find this stuff, but we're just gonna kind of put this kind of hashtag documentation in here so that we can use this. Like if we do this, it's probably not in the documentation anywhere yet, right? So what we're going to do is we're going to make a note here. So video 183, correct? Yeah. So at vid IID 0183, and the time is 0028, and then let's just say 13, make it a lucky number, right? Looking for resize procs, right? We're looking for resize procedures. And we're trying to figure out, like, where does that happen? So one of the places where this is happening, one of the places where some of this is happening, locations. So there's a few locations. So this is definitely one of the locations, right? We looked through it. We found this location, but there's more. There's something else somewhere else. What we could do is we could think, hey, somehow this data gets pushed up. It somehow gets pushed up, so maybe you want to look in the library and look in main and say, what do we got here? We got sync with GPU, blah, blah, blah. So if we, okay. So the data in Tau Depot, we look at Tau Depot's data, we should have a variable that stores the user interface rectangle. Not the user interface rectangle, well, we do have that as well, but we should have an actual rectangle in the PAINT5D system right? The viewport 0. VP0, the destination screen viewport, right? So this VP0 here is the rectangle that's getting changed every time we resize the screen. And so at some point in time, this VP0 is getting uploaded. And chances are we're not using this directly. Chances are we're using this P5D VP0 variable. So what we're going to do is we're going to find in files, and we're going to look for that P5D VP0, and we're going to find in files, and we're going to look for it. And somewhere where that's being referenced, it's gonna lead us to exactly what we want. So PAINT5D functions. That looks possible. Tau sync, fragcom, fragment shader common code, P5D OGL, tau frag, shader code. Okay, so I think that the most likely place is probably PAINT5D, because PAINT5D manages the editor. It's the CPU side code for the editor, right? And this window resizing stuff is on the CPU side, as far as I'm concerned. So we double-click this, and we take a look in here. Let's just take a look in here, because so info PAINT5D, this isn't exactly what we want. So it's a get function call. Somewhere we should have a put. Here's a get as well. Where the heck is the put? So here's the rec P5D VP0 get tau depot get fragcom. Okay, we're mapping. It's a mapping thing. Drag. Oh, there we go. Here's our put. Right here. So we're putting all of them. Right, we're putting all of them. So somewhere this function is being called. So I'm going to put this in my notes. So I'm pretty sure that 2, somehow that's being called from somewhere, right? So, so if we look in here, we can see, oh, hey, it's called here. Okay, well, what function are we in here? Is this like a loop tick function? It's probably a loop tick function. Nope, initialize or update. So, so in here, so this is 2.1, right? This is 2.0. This is 2.1. So this is, or do we want to do it like that, or do we want to do it like 2.0, 2.0.0, right? And this is item 2.0.1, right? Because, oh, wrong order. Oh, no, yeah, initialize or update, right? So initialize or update calls that IOU function, right? So yeah, this PAINT5D put rec all. This thing is called from here, right? So from here, we branch into here. I don't know, maybe this is a crazy way to be denoting our functions. So what we're gonna do now is we're just gonna keep on looking, right? So this thing is the current top level, and if we trace through here a little bit, we'll see. Okay, initialize or update. So where are we now? So we're in the init function. We're expecting that only to be called once. And then loop tick. Yeah, PAINT5D loop tick. Excellent. Okay. So the loop tick calls. So this is 2.0 dots. So it's really, this is more like 2.0. Or 2 dot, okay, so then at this level, Yeah, let's say 2.0, 2.1, so 2.0.0 is this, and then we branch into here, right? 2.1 going into a different cell here, and then this is 2.1 and branching to 2.1.1, right? I don't know. Maybe my branching is kind of like stupid, right? But this is kind of like this is the top level. This calls that, right? I don't know, maybe I'm just getting way too complicated trying to write this. But yeah, so we have kind of this list of locations, and that's pretty good. That's pretty good. So actually, let's kind of shift that. So yeah, we have the locations, and now we can also make a note here, right? So at vid IID 0183, and the time is, what's the time? 35 and 36. Let's make it 36 and 13. Let's say 3613, because found so I don't want to say I found all of the locations, right? I don't want to say I found all of the locations because I'm not certain about that. But these are the locations that I think I want, right? These are the locations that I'm kind of interested in. And so we have this put rect inc all, right? So rectangle inclusive all. And what are these rectangles? Because maybe this function signature just needs to be edited. So we have VPC, we have VP0, we have VP1. Okay. Now, this function, how does it behave? Like, does it calculate where these rectangles need to be? So it looks like this is just a wrapper. It's not doing any of the calculation. It's just kind of wrapping kind of these are very clunky functions here. This put function, very clunky, right? So it's just a wrapper for this clunkiness. But yeah, I do think that this is what we want to edit. So in here, we're probably calculating where some of these things need to be, right? So let's just give each viewport's bounds kind of a different color here, so that we can look through the code and kind of assess if we're doing the calculations here. So assert that these are all like greater than or equal to 0. Okay, so make sure they're not negative, right? Because they should be on screen. Okay, yep, so positive rectangles. Some code. Okay, yeah, so calculate canvas viewport that covers context. Excellent. Calculate destination viewport. Excellent. Possible problem if we are manipulating this with user controls. Does this create a problem for us? Set the data viewport zoom all the way so that we can see everything. Okay, fine. Let's remove some of that extra spaces. And let's just let's add one more calculation, right? So first of all, we have this code over here, and I do like to separate things into functions and data. So now that we know kind of where this calculation happens, we can put it over here. Now the problem is that once we put this over here, right, it's technically in a new instance of Notepad++. So that means we have to kind of go back through and find where that update. So I know we call it like init or update, so we can go like IOU, init or update, to find that code again. Init or update viewport rectangles. Yeah, so right here. And here are the rectangles we kind of currently highlighted, right? So we highlighted all of the variables for all of the individual rectangles, right? So these clusters of variables are conceptually individual objects. So this is conceptually one object, this is conceptually one object, and this is conceptually one object, right? Okay, so now we want to add the UI rect right here. So we want to keep kind of the same kind of naming scheme. So first of all, @vid IID 0183, and the time is what, 0039. Let's just say 0040 because that's what it's about to be. And 4002, 4004. I like 4004. Let's just call it 4004. Calc Uifrags Uifrags dot P5D. There's no such thing as Uifrags.p5d, but we're just kind of writing it that way. So that, okay, so int32, and it's going to be like uint rec1 x0, right? So it's going to be kind of this format. We have no clue what's going in here yet, but let's kind of paste this 4 times, and let's just steal these variables, right? So steal these variables. So uirect1, right? So we could say, you know, p5d ur1 dot x0, right? So conceptually, this is kind of what it is. This doesn't actually exist. This is a conceptual thing. This is not actually a thing. But it may be helpful for us to denote this. Now, it actually might not be a good idea because the calculations might actually start to take up quite a lot of room. And yeah, but for now, we got to think, well, what do we want? So we wanted the destination viewport. So let's go look at our notes here. Up here, here's the destination viewport. Here's the off-screen viewport. Here's the canvas viewport. So this is the destination viewport. This is basically our camera, right? Make sure. Think about it. Think about it. Yes. So VP0 is our camera. And so we want it relative to... So the first thing is, let's make everything anchored. First of all, let's anchor to the top left corner. So we got the X's and the Y's. And X and Y. Yeah, so let's just anchor to the top left corner for now. And then we want to say, okay, well, how do we kind of make this wider, right? Well, to make this wider, the minimum has to be, we have to subtract something from it, right? So we already have this is already a 1x1 rectangle. So we don't want to subtract the width of what we want. We want to subtract the width, and then we want to add 1. So UR1 width plus 1, right? So that's kind of what we want. And we can kind of see why we didn't want this because of this commentary, because it was going to start making problems for us. So let's kind of reduce some of the clutter in here, right? We already have that redundant. We don't need that. So this UR1 width, right? And then this is for the minimums. For the minimums on the X, okay? For the X0 here, so we're going to put it over on the left, right? So minus, you know, minus 0, right? Nothing in here, plus 1. So we're going to keep it like that. We might as well put the curly braces, not the curly braces, but the bubble brackets around it like that. So it's a little bit easier to see where we can kind of like swap out that 0 for something meaningful, right? So this is just changing the width, right? And so the code on the Y, we're going to take we need this user interface to be the same width and height, right? So so hashtag same height. Let's call it Sam high. So let's do @Sam high, right? Because there's going to be it's going to be a @ comment rather than a hashtag comment. So it's a more generic comment, but @Sam high for @same height, right? That's what Sam high means. That's just what I decided it means, right? So this y0 and this y1, they need to just directly match, right? So that basically means that the height of the user interface is going to directly match the viewport, right? It's just going to snap to the viewport in terms of the height, but the width is just going to be left justified, right? Left justified. It's going to be on the left side. It's going to be left side. So make P5D interface 1, same height as viewport, and 2, snapped to left side of viewport, right? So same height as viewport, and snap to left side. So same height. Maybe want to emphasize what's important here, right? So as viewport. Snapped let's just call it snap to, right? We don't have to use proper English here, right? We just want to make the comment in a way that we want to be able to see the patterns, right? So same height as viewport, snap to left side. So we could say left side. So as and of. As viewport, of viewport. So, sure, why not? So those are the constraints that we want, right? And these are the constraints we think we're calculating. Now, we could be wrong, but I'm pretty certain that that's correct. So the next thing is, okay, so we're satisfied. We're satisfied, and we're like, you know what, we got this, we nailed it, right? We nailed it. Except I'm seeing a problem here. Why is this like this? Is this proper? Right? Why do we have these two here? This looks like a mistake. What is it? Nope, because it's the left side, right? So in order to remove this pattern here that looks like a mistake, we might want to define a macro really quick. Define left side. And then maybe, man, we're so close to getting that kind of aligned nicely. Well, actually, we could just do that, right? We could do that. It's a little bit cluttery, but we could do that, right? And now it says left side and left side here. And then after we're done using it, we'll just undef the thing that says left sid for left side. And then in here, where this looks like a mistake, we can change this, right? So the idea there is that now when we look at this, left side and this and that, and then kind of like this and that and this and that, right? When we look at this, this looks less erroneous, right? So the idea is just that macro does add extra indirection. But now when we're looking at the code and we see this kind of weird asymmetry of this left side and this, it doesn't look like a mistake because originally it looked like one should have been x0 and it looked like the other one should have been x1. But that's not the case because it's just justified to the left side rather than the right side. So the left side was x0, the right side is x1, right? So that's good. Okay, cool. So now that we have that, we want to go down into where we're making this master call here, right? We're just calling this ridiculous function here. So UI rect UR1 and then, you know, blah, 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 blahs, right? And let's just take this and cut, paste, cut, paste. So just bam, bam, bam. And then this is P5D UR1, right? So if we look here, we can see P5D UR1, right, for UI rectangle number 1. And in here, we can just steal the kind of things from up here, right? So this is X0, this is X1, this is Y0, and this is Y1. Okay, so now that we have this, we're going to go find this helper function. And we already have kind of this very terse syntax here. So we're going to duplicate this line. And this is now P5D UR1 for UI rect1. And then we just need to replace all these with UI rect1. So UR1, 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 and UR1, right? Okay. So now that we have that, we need to go actually implement that. Now, the first thing we might want to do is just look at the last place where we did this stuff, right? And that'll help us know where to put this stuff, right? We'll put this orange stuff right after wherever the cyan stuff is. So, first of all, I'm kind of scared here. Bounds checks. Out of bounds checks. I see how that could be scary. Do I really care, though? X and Y, so here's the lower, okay, so lower bounds checks, rough out-of-bounds checks, and specific out-of-bounds checks. Okay, fine. We can roll with that, So we're going to take this code here, paste it, and we're going to say UI rect1, right? And we're checking the lower bounds and just making sure they're not negative, right? The rough out-of-bounds check in the upper bounds, we're going to take this, and this is going to be UI rect1, and x1 and y1, so it's the upper bounds. Also, this right here, we want to paste this, so UR1, the message should be different now. So this needs to be UR1 now. Okay. You can see kind of why I'm making this right. So we could give this a really long name and call it like user interface rectangle number 1, or user interface rectangle sidebar UI buttons, whatever the heck, right? We could give it some type of fanciful name. But in the end, that doesn't really help us, right? It just clutters up the code, makes the code less terse, makes the code less manageable. We have less ability to streamline the code when we make incredibly long names like that. And in the end, I've found that by trying to come up with a descriptive name for stuff, a lot of times that doesn't give us any information, because eventually we have to actually look into the code and be like, okay, what is sidebar UI buttons rectangle whatever, right? We have no clue what that is, right? So UI sidebar rectangle whatever the hell is just as obscure as UR1 as far as I'm concerned. Okay, well, maybe not when you say it. Like, okay, you know what? Let's phrase that again. UI sidebar rectangle gives you a false sense that you understand what the variable means. UR1 does not give you a false sense. And so you just have to find where UR1 is defined, right? And then you see this UI rectangle 1, and then you can kind of look at some diagrams, and then you can know what UR1 is for, right? And then once you know what UR1 is for, then you don't have to worry about it. Now, maybe I'm being too terse, and we could say, oh, but people should be able to make assumptions. And I do think people should be able to make assumptions, but let's not let that get out of hand and get in the way of having nice, organized code. So I disagree with the idea that you shouldn't put numbers in variable names, right? So we'll have a UR1, a UR2, a UR3, and what those different UI rectangles represent will depend on what the documentation says, right? Which also makes it easier to refactor, right? Because if we ever change what UR1 does, what it's for, we don't actually have to refactor any of the actual code. We just have to refactor the documentation. And there's no such thing as a trivial refactor, right? There's always something you could break when you refactor code. So by making the only thing that needs a change the documentation, we have less problems on our hands as far as I'm concerned. Okay, so anyways, let's go highlight this stuff orange again, because we should now see it over here. Yeah, excellent. Okay, so this XY, XY, zeros and ones, excellent. XY, XY, zeros and ones. So do we have a specific bounds for this? So VP1 is in terms of, so that's actually kind of confusing. Why is VP1, VP1 is the off-screen viewport. VP0 is the destination viewport. Did we make sure, let's make sure that we made sure to make that code relative to, when we were adjusting the rectangles, holy crap, we're going to have to obviously, well, first of all, if we just go look for P5D Uirect1, if we go look for that for a second, we can find the calculations. So not here, but over here. Is this in relationship to the VP0? Yes, it is in relationship to VP0. We can see the VP0 right here. Okay, cool. This is left side. Excellent. So I'm just making sure that that's correct, because if we get that wrong, right? I keep on forgetting what VP0 and VP1 is. So you could say, oh, look, there's a reason why you should have long variable names. Nope, you're just trading one problem for another. I like my code nice and terse and streamlined, so no. Okay. So this bound, right, this bound is not in terms of screen pixels, screen fragments. This is off-screen buffer. And this is the 256 minus 1 is the addressing space on the X and Y of the canvas user view, which is in, I think, the PAINT5D diagrams and the PAINT5D data file go over that. So let's go look at that for a second. So in PAINT5D, not the functions. So let's look at PAINT5D functions here, or PAINT5D data. There's a thing called canvas user view. So this thing right here is conceptual. This thing is 256 by 256. So this is the smallest number of pixels in which every single layer and every single tile size can be represented all at once for the auto tile set that is in focus. Boy, that's a mouthful. So you could think of this as the like a camera view. You could think of it as like right, it's what the artist sees, but that's a general approximation, right? This would be what the artist sees if they resize the screen so that the viewport was exactly 256 by 256 pixels. If the viewport's not exactly 256 by 256, then this kind of schematic gets shrunk or squashed and remapped accordingly to the shrinking and squashing. So it's not exactly, it's kind of like a mapping. But anyways, that's there. Okay, so we got this bounds checking code. And then, so we have tau depot put. So we have the put functions, and this put function. So we want to go after the cyan is where we want to put the orange. So all we're going to do, all we should have to do is just repeat the patterns, right? So we should be able to paste this here. And the thing that needs to change is this needs to be UR1, Uirect1. And then these rectangles, instead of being VP1, they're going to be UR1 for UI rectangle 1. Okay. Okay, so the next thing we want to do is a spot check. So a nice little spot check is where we just go bam, 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 and bam. And then we just go bam. And we just want to make sure that if we spot check this, we don't want to see these colors mixing, right? So if we haven't made any stupid transposition errors, then all this should be the same colors, the same groupings. So if we kind of like procedurally go through here, now these things, right? These things should be the same. These things should be the same because all of the data is in this top level cell subdivision of the Tau depot memory. And then within that subdivision, we're looking at PAINT5D variables, right? So everything is a PAINT5D variable that we're editing. So these two should be the same. So I'm not going to highlight those. This should all be the same, right? Because this is where we're grabbing at those constant values, or those, yeah, constants, right? Constants, not defines, constants, right? And this struct kind of like holds that configuration for us. So that all looks good, right? So that looks good to me. And we're not going to see any visible changes, right? We're not going to see any visible changes. But we have this here. So the next thing is this rec inc all. Is there more than one call site? So here's a call site here. Is there another call site? Nope, there's just this one call site. I think we're good. So if we give this a run, we should not see any changes. We should not see any changes. But what we should see, or we can just, you know, blow up like that. So once we get this compiling, we shouldn't see any changes. It should just be ready for us, right? So the UI rect width, we have to figure out what that needs to be. So we didn't figure that out yet. So that was kind of like an unfinished thought. And we'll just kind of like hard code that somewhere, right? So if we look at, well, it says UI rect 1 width. So I think that probably belongs in the UI rex data, right? So if we look at the UI rex data, we have UI rex data, UI rex this. So I'm thinking some of this code could kind of be better organized. Sizes, dimensions of UI rex. So let's just make a section here for dimensions of UI rex. And this is where we'll kind of put this kind of code here. Okay, dimensions of UI rex. And within this code is where we're going to create some type of constant. So we'll say like define AAC 2020 UI rex. So we want to know exactly where it's coming from. It's a... Hold on, I go upstairs, make sure that my timer for the food isn't going off and I'm going to get yelled at. Okay, so food had 30 more minutes, but that would mean that it would go off at like 7:30. People don't actually get up that early in this house. I mean, they get up at like around 8 or 9, so that would be a little bit too early. So I turned the timer off on the stove and set it to... I just turned the timer off, and then I set the temperature from 250 down to 200 just to keep it warm and let it cook more thoroughly. So it's gonna, in 30 minutes we'll have been in the oven for 3 hours, so it should be fine. I kind of slow cooked it. Okay, so anyways, we want to figure out what this needs to be. So Uifrags, right? And we want a Uifrags for PAINT5D, right? So Uifrags PAINT5D. But we could just say P5D UR1, right? So that's the variable name. Uifrags P5D width, right? And that width could be that width would be what do you call it? I don't know, man. Actually, I do know. It's 7. There's going to be 7 characters. And each character is, right now, going to be 8 by 8 pixels. Now, that's still kind of hard to look at, right? So... let's do this. Define AAC 2020 Uifrags 64p, 64 pixels, 8 glyphs, PNG, and glycan, and that's the glyph span, right? So glycan. So we're going to make a note of that, right? So glycan, I think glycan is fine. We can call it glycan. It's a ridiculous name, but in our variables, right, we can just say, oh god, we're losing our spot here. So we can say glycan, and then glycan U plus bonds hexa. Why do I call it bonds hexa? I don't even remember, but I remember that it's a checkbox. So glycan, and then glycan, glyphsan, I hate this. Oh god. GLYPH span, GLYPH span, GLYPH span, or G-span. Okay, so if we type any one of those, we'll autocorrect it, right? Now, if we do it backwards, if we do like sangly, right? Sangly, sanglyph, GLYPH, san, GLYPH. If we do any of these backwards versions, then we're going to say, hey, that's backwards, you can't do that. Span of the glyph, span GLYPH, span G, span underscore G, and then span G. Spang? I don't think that's a thing. So backwards use, right, to make sure we're trying to reduce our memory footprint here, because this file does nothing but grow, and we're not getting more RAM. Eventually we should probably get more RAM, but I don't want to risk opening up my computer and damaging it. So until performance just kind of like becomes impossible to do stuff, we're not going to worry about that. So backwards use glycan. Okay. So now the next question is, well, what is glycan, right? So glycan means, and glycan means, okay, so glycan, glyph span equals, right, span is when width and height are equal to each other. That's kind of what I mean. So that's cool and all. But the other thing is that I see the potential to write it as, instead of gly, G-L-Y, I could see me kind of spelling it as G-L-I mistakenly. So in all this code, we're just going to be like, you know what? If we see kind of like this, it's spelled the wrong way, we're going to fix that, right? But that also means that the G-span things, we can just delete these from here, right? So, okay, cool. And then backwards, baka, backwards and wrong. Use, actually no. Backwards and wrong use. Okay, so baka means baka means it's gonna be like some Japanese horrible swear word. Yeah, actually maybe because baka means like cow or stupid. So baka woo, I don't know, maybe. So backwards and wrong use okay, so this looks kind of good. So actually no, this is just wrong. It's gly. Okay, hold on. Yeah, use. Oh, that's my mistake. Backwards and wrong used glysan. Okay, so just wrong use ... Okay, cool. So now we have kind of like these right, if we kind of like try to type something that is kind of like close, but not quite, that'll catch it. And so we might want to make like a little divider line in here, right, in our shortcuts. And then up here, we can throw this in here like that. Okay, cool. So let's go throw this on our other monitor and say, you know what, we're good there. Let's kind of keep on rolling. Let's keep on rolling here. And so we're thinking, what were we thinking here? So glysan for glyph span, right? That's what that means. And the glyph span is 8. And we're going to use that in here. So we're going to say, hey, define glysan as this. And the reason we're going to do that is so that undef glysan here, we're going to do that so that this looks less cryptic, because right now it looks cryptic as heck. So we also want the number of glyphs in a button. So Glyphs in one button, IOB, and one button maybe, Y, IOB, and that's going to be 7, right? So glyphs in one button. I don't know. Sure, why not? So define glyphs in one button. It's going to be this, and then we can undef it right here. So this is going to be here. So this and this. And we can also make a note of this, right? So we can make a note of, like, what does this mean, right? So we can say glysan, glyph span in pixels. Okay. And then IOB, glyphs in one button, right? So GLY glyphs in one button. This is glyph span. This is the glyph span, and this is glyphs in one button. So if we want to kind of like write that in a way where the abbreviation kind of makes more sense, span, right? In pixels. So glyph span in pixels, glyphs in one button, glysan and IOB, right? Is that kind of weird? Yeah, it's kind of weird. It's like why, but now we can do we can go glyphs in one button, IOB, times the glyph span, and then we get this, right? So we can now have kind of this calculation where that is kind of still kind of big, but now we have this width here, right? And this width is compile time constant. And with this width, we can do things, right? Now, the other thing is we might want to have a height variable. Now, the height variable is going to be the same size as VP0 So we're not actually going to use this variable. We're not actually going to use this height variable because it's going to be the size of P5D VP0. So we just put a string in here and put some nonsense in here because it's just going to be the size of VP0. P5D VP0, because we can see the VP0 calculations over here, right? So we're just making sure that the height, so when we're looking at the height, we're looking at the y, and we can see, oh, this y0 is equal to VP0y0, this y1 is equal to VP0y1, right? So it's just the exact same height as that, right? So now that we have this in place, we could take this width variable, and so this UI rect width here, we can say, hey, I know what we need for that, and define UI rect1 width as this thing. And then down here, we can say, oh, undef that. UR1 width. Excellent. Do we want to just, like, kind of do this? I don't know, I kind of feel like it. I don't know if it's right, but I'm doing it. Okay, cool. So, big cluster of clustery clust. So does this +1 make sense? Well, let's say that, we're on the left side, and the rectangle is exactly 1 by 1, right? Well, on the left side, we're already on the correct pixel. We -1, now we're outside of the bounds of that 1 by 1, so we want a +1 to end up back in the bounds. Okay, so that makes sense. That is why there's this minus and plus pattern going in here. The off by 1s really can get you sometimes. Okay, so I am happy with that, and let's give this another shot, see if this will compile for us, and then we'll add some rendering code somehow to say, hey, if we're inside of here, let's go and render this, blah blah blah. Define UI rect1 with blah blah blah, an expansion of macro AAC UI rex P5D UR1 width. Define UI run width. Expected GLY IOB undeclared. Okay, got it. So let's go in here. So GLY IOB is undeclared. Why is that? Because this looks like it's right here. We define it right here. Then we have to define this right here. And this is defined as this. Ooh, hold on. These UI recs are coming before Paint. No. PAINT5D system comes first. I mean, PAINT5D system comes after this, so that's fine. Okay, hold on. Where's the code going around here? So, error. This thing is undeclared. First using this function, define this GLY IOB. Okay, so GLY IOB. First of all, let's make sure that it's not a typo. Okay, so let's look for this exactly, because we probably like swapped out maybe a 0 for an O, maybe. No, it's right here. And then it's right here. And then it's right there. It's right here first. It's right here then. It's right there then. Hold on. Why the heck? Okay, well, is this the same? Is this exactly the same? Let's match case. Hold on. Let's match the case and the whole word only. So that's there. Okay, cool. And glycan. I don't know what's up with that. An expansion of macro AAC 2020 UIREX P5D UR1 width. So this variable right here, it's saying undeclared. And it's right here. Oh, hold on. Is this correct? Did we get the casing correct here, or did we make a mistake here? So let's copy this for a second. Maybe we made a mistake here. No, it's right there. And this comes after, this is the PAINT5D functions, so the data should come first, so that should be okay. What file are we in which this happens? It's in UI rect width 1. So it's happening right here. Part of me thinks that the reason it's not working is because in the macro, I'm thinking that maybe what's happening is that this undef is destroying this macro, right? So I might want to do like a C99 static assert, right? So we might want to do a static assert, and we might want to say, hey, assert that glycan right here is equal to 8, right? And then also assert that this gly IOB, that should be equal to 7, right? So gly IOB, it's equal to 7. And then, you know, bad mac glycan And this one here is badmac gly IOB, right? So badmac, glysan, and gly IOB. And then instead of using it directly in here, I know this is ugly as heck, but let's put a 7 and an 8 in here, right? So, or 8 and a 7. And what I'm thinking is that if it's still broken, it's broken. But I think that there's something about I'm questioning that I don't actually understand how macros work. Like I obviously have a lot of working knowledge where I get by, 95% of the time. But it seems to me like I don't know how macros work. Yeah, look at that. That works. So undefining them just made it so I see. So undefining it, not a good deal. Okay, that's fine. That's fine if that's the way you want to roll. That is kind of sucky though, isn't it? There should be a better way to do this. So do we really need this to be a compile time constant, or do we want to start creating a Uifrags struct, right? We could start creating a Uifrags struct. I think that might be a better way to write this, right? There's no performance consideration I need for this, so, well, I guess there's always performance considerations, but Uifrags library struct, right? So we'll create a library struct section. And we'll just kind of like do the same thing we did in Tau Depot, and we'll just kind of bounce these into these containers. So struct AAC 2020 Uifrags, okay, and then open that up, let's close it off, and then within it we're going to say it's going to have a struct AAC 2020 Uifrags PAINT5D, or we could say, yeah, PAINT5D, and we could call it, we're going to call this PAINT5D, right? PAINT5D is the name of this substruct. And then also Uifrags, what do we call the placeholder in pixname? Let's go in pixname for a second and look at that placeholder. So in pixname data, to do 0, to do 3, right? So we just called them to do, which it's actually just a placeholder, right? So eventually they're going to exist, but to do 2. Right, so we'll call this to do 02. And what we're doing here is we're just adding these so that we can create a pattern, right? So that when we're trying to add to it, we can already see kind of a pattern. We can see an established pattern, and that'll make it easier for us to know what to do, right? Okay, so in this struct, in the PAINT5D subsection, we're just going to say a U08. And then we're gonna say like we're just gonna call it UR1 width. Do we want to call it UR1 width, or do we want to call it like literally PAINT5D? Right, PAINT5D UR1 width. Right, so make everything capital and then make the terminal node lowercase. I don't know. I don't know what I want to do. Does it really matter what the terminal is? Is the distinction of the terminal node really that important to us? I don't really think it is. And it's actually a constant, so let's not do that terminal node BS. Let's try to be more consistent. P5D UI rect 1 width, right? So sure, why not? Const U08 P5D UI rect 1 height. And there is no such thing as that, right? That's not a thing. Not used. Same height as P5D VP0. Right, so there's no calculations for that. This is the same height as P5D VP0, but this actually does need a specific width to be set. And then we need an initializer, right? So this UIREX struct, that's not quite the correct syntax, right? Because we're going to declare the struct, and then we want to create an instance. So we're going to say AAC 2020 UIREX, and this is going to be AAC 2020 UIREX library struct, right? So we'll name this we'll name this kind of this, right? So if we highlight this, we can see. Oh, I guess that didn't quite work. If we token highlight this, though, we'll see the other thing, right? We'll see them all in the same section there. So I don't write library structs that often, so sometimes I'm a little fuzzy with the syntax. But equals, we need equal sign, and then we need the initializer list. And so basically what we're doing is, so you can do struct, name of the struct, name of the variable, right? Or you could do struct, instead of the name of the struct, you can have the actual definition, right? So you can use substitution. If you're wondering like why you can do this syntax, that as far as I'm concerned, that's the way it works, but I could be wrong. Okay, so with this, we want to say, hey, ooh, I should check my Stack Overflow, because what if that was a message from... Yeah, I better check my Stack Overflow. Like, it could be somebody just telling me I'm full of shit on Stack Overflow, but it could be Yevgenos might need me to give them a good word. So I might want to get that Stack Overflow inbox. Okay, so UIREX, and what are we doing now here? So UIREX something. Okay, so we want to do dot, no comma here. Dot PAINT5D dot P5D UIRECT1 width, and we're going to set it equal to set it equal to the glyph span, and we're going to times it by number of buttons or something like that. No, not number of buttons. IOB, what was that? I know I just made this variable up. IOB, glyphs in one button. Got it, yeah. IOB, in one button. And does this initializer require semicolons? Nope, it just requires that we have commas. So now for everything else after this, we can do PAINT5D dot P5D. You don't need anything. not used. We could just keep this, right? So this is a string, right? So why not just, for kind of the ease of doing this, just set it equal to this. And then instead of making it a const UO8, we say const const char, and then define UO8, define chr, define char, const char, and then that const char. Oh yeah, because this is going to be a const char pointer, right? Because it's going to be a string. So const char pointer, and then down here, right, we're just going to set it equal to this, right? And this is a hard-coded constant. This is a define right here. So we're just gonna set it equal to this kind of string literal here. I don't know if we can yeah, I'm pretty sure we can hard-code it like that. So it's unused, but I just want to be able to establish a nice pattern here. And I think that's good. Have we made any mistakes? I'm sure we made plenty of mistakes. Okay, so the first thing is, before we even change anything, right, we have this kind of hard-coded value right here. Before we use something besides this define, right, we get rid of this define and just use this object directly. We're going to want to just make sure that we haven't made any stupid syntax mistakes, because I think that we probably have. I mean, I'm pretty good at it. Struct has no members. Error, struct has no members. Okay, sure. And that's kind of why the Microsoft documentation has that int unused. Stop yelling at me, compiler. So we just want this to establish a pattern. Okay. So now let's kind of like do this. So I get why that is, because if the struct has no memories, if the struct has no members, then the base address cannot point to the first member, right? The base address, like, how do you make a whole bunch of structs with no members in it, right? How do you make an array of that? How much memory does that take up? 0? Okay, well, if it's at a certain memory address, then what's in the base address if there's no members in the struct, right? The address of the struct will point to the first element within that struct, right? So unknown field P5D UR1 for UIRect1 unspecified. Okay, so P5D UIRect, oh, because this is height. My bad. Okay. And so we're trying to keep this as flat as possible within reason. So any kind of large groupings that we have, we will nest them. But if it's not a large grouping, we're not going to nest it, because it just ends up nesting things too deeply is just asking for trouble in my experience. Okay, so this is here, still here. Let's change this around now. So let's just get rid of this stuff, right? So let's just say the dimensions of these user interface rectangles. We're just gonna comment all this out. Bam, 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 right, like that. And whoa, oh my God! Whoa, what time is it? Holy crap! Wait, 7. Oh, wait. Hey, I didn't see your. I'm going live on what was it? I didn't see you're going live on Discord. It was Discord. Don scammed me out of my channel points. That sounds scandalous. That sounds like am I getting thrown into some drama here? Because I don't want to be thrown in any drama here. Anyways, I'm sorry for your loss, N. Perry. Um, okay, so right now I'm trying to get like a rudimentary like user interface. Adult things to do. That's good. Good. Be an adult because I can't. I mean, in fact, did I mention that Monday is my caffeine day? So I'm still on my cup of coffee from yesterday because I make it super strong, and so I've been up since yesterday, and I thought I was about to go to sleep. Then I started some stuff on Facebook, got an adrenaline rush from people arguing with me, combined it with some caffeine. I'm like, man, you know what? I feel like writing more code, and now here I am. Now you're lucky because yesterday my bit rate kind of sucks sometimes because there's too many people in this house, but right now it seems kind of okay, but it may kind of suck later. Oh, let me show you something. Yeah, I gotta stop getting myself in trouble. There's nothing good comes from Facebook, I swear to God. So in my Imgur for a second, I did this yesterday, when Henry threw people my way yesterday. My bit rate was horrible. And I did upload these images, but I don't think anyone saw them because the bit rate was just horribleness. So let me go find that gallery, gallery profile, and let's go throw this into, oh, here we are. So I've noticed that I need to find a GIF website that is appropriate to game development, because most of the times when I post techie stuff, I end up getting massively downvoted. So I've been trying to even it out with kind of memes, and that's been working pretty well. But then every once in a while, I want to like throw something super technical, and then like I get like downvotes. But anyways, that is the gallery for the first like 10 little animated GIFs that I think I've been showing people of the old game engine. So I'll just go through these really quick, right? Preloader screen, fancy stuff done with tiles, a little checkbox thing to make sure you agree that there's a seizure risk, right? So, oh, by the way, there's a seizure risk. I hope nobody hates flashing lights. If you know, it's probably already too late. I'm sorry if any of you are dying right now. Anyways, so I wrote some kind of little descriptions about what you're seeing in each one of these GIFs, right? So that I don't have to keep on going over it. Right, and I just kind of like, I collected these GIFs before Flash was officially disabled on Chrome, and it seems like Chromium-based browsers in general aren't supporting Flash. Whatever, it's I gotta just move on. I took the screenshots, and now I'm never gonna play it again. So I gotta code a new engine. So what you're seeing here is the actual kind of gameplay that I want this. Yeah, yes, exactly. Spam F. That's yes. We need some. What is it called? F spams in chat. So this is the actual mechanics that the game engine is gonna need. But the problem with this game engine is the lack of. There's a lot of visual monotony, right? Because it's a whole bunch of auto tiles, and while auto tiles make things look nice, you only have one. I don't want to call it a level of detail, because level of detail is kind of like an OpenGL thing, right? You only have one level of artistic coarseness, right? So when you're trying to make like interesting art, you need like coarse level details, and then you need fine grained details. You need to mix and match the density of information that you're seeing in the artwork, so that you can break up the visual monotony. I don't know if that makes any sense. I'm probably not explaining that very well. But you can, if you look at this, you can see the same level of coarseness in all the graphics because all the graphics are the exact same tile size, right? You can obviously see that this is built on a grid of tiles that are all the exact same size. So we need some type of better rendering tech that can support the creation of destructible geometry that is that will just not look this crappy, right? We want to do destructible geometry, we want to do auto tiling, but that doesn't mean we have to use crappy 8-bit graphics, right? We can do fancy stuff, right? So we also want like a lighting system, right? So we want some fancy lighting, right? So by the way the lighting system is done is you have geometry tiles that can emit lights, and before the game starts, before the level starts, we calculate where rays of light are hitting different pieces of geometry, and we render a thing called a light map. And the light map is just one bitmap that's overlaid over the entire level. And when we break a light in the game, we figure out which cells of the light map are dirty, and then we re-render those sectors of the bitmap. And so we get kind of the illusion of dynamic lighting, but it's not really dynamic lighting. It's not quite dynamic lighting, but it's not quite completely pre-baked lighting, right? It's kind of this hackish compromise because this is action script code, and if we want to have nice shiny things and get a whopping 30 frames per second, we gotta do some tricky stuff, right? So here, right, just, you know, skulls are instant kill mines, but the other mines are proximity mines. I actually do not like these lightning bolt graphics. So the old graphics for these bombs actually made a lot more sense. But anyways, let me actually show you those old graphics while I'm here. So where are we here? Somewhere in here, probably in like the way old back in the day, like 8 years ago, literally. If we go all the way back 8 years ago, we can probably find like some old screenshots that have, right? So the old screenshots were like crazy, the lighting engine was like out of control, right? So the lighting engine was like, whoa, that's kind of crazy. And this is also watermarked, but like the lighting engine was kind of like, I was kind of going for like a crazy lighting engine with like think it like a neon survival horror is kind of what I was going for. But my game designer was like, you know what, I can't focus with all this crazy lighting, right? They're like, this doesn't really make a playable game, so, you know, please tone it down. So I toned it down. I think the next engine design is going to have like the option for like a sparkle mode where you can make the lighting go all crazy. But yeah, this was kind of like overkill, complete overkill. So anyways, yeah, I could, like, it's crazy because some of these initial level designs were really cool. We changed kind of the level design from the original game design was basically, there's one room, there's 2 buttons, press one button, things will explode, but you'll be safe and you'll be able to get to the exit. Press the wrong button, and everything explodes in a fantastic way, and it kills you. So it's like a Rube Goldberg machine of death, and it's just like, pick one button or the other, right? So a very dead simple, kind of stupid game, right? So this is kind of, no, that's not quite it. I don't know if we have one of those death trap things in here. Yeah, I don't know if I have that. Yeah, unfortunately this GIF is really small, but this was one of those death trap things. There's like 3 buttons, and you have to pick the correct one to get through the level. Yeah, just a lot of cool stuff. Anyways, I was going to look for the actual bomb design in here. You can kind of see it here. So you can kind of see it right here. So the bomb, the 4-way bomb has a cross in it, right? So you can tell that this bomb is going to explode 4 ways because there's a cross, right? Right now, the bomb is like some... right, there's like lightning, there's a lightning bomb and a ice bomb and a whatever bomb, and I let my artists kind of do whatever they wanted because I wanted them to have some creative control. Next time I think I'm going to be a little bit more heavy-handed with my guidance here. Oh, there goes my bitrate. Gotta buy a, yeah. Anyway, so you can kind of see here, you can see kind of this vertical dash and four-way dash, vertical dash, horizontal dash, and there's actually a four-way dash here, but the watermark kind of hides that. Oh well. Anyways, yeah, so there's kind of stuff. Anyways, let's close this, and let's get back to trying to get this code working. So, if I can get this compiling, and we're really close to getting this compiling, I just got to change a few things. So this macro here, we just commented it out because we're going to use AAC 2020 Uifrags dot PAINT5D dot P5D Uirect1 width. Boy, that's a mouthful, right? That should be correct though. So P5D Uirect1 width. So this kind of stutters, right? Because PAINT5D here and P5D, they actually mean the same thing. So this right here means the same thing as, oops. So this right here means the same thing as this right here. So anyways, let's give this a run, see if we can get this working. And yeah, this sucks. That my bitrate sucks. So I apologize. Bitrate. Yeah. I apologize that the bitrate sucks. I will not hold it against anyone if you leave now. Because, man, listening to stuff that's really choppy kind of sucks. Okay, so Uifrags declared here, not in a function. Uifrags data. Undeclared here. Oh, is it because we undeclare the macro and then we try to use the macro before it's... Okay, so this thing right here... Hold on. Oh, yeah, because we commented that out, but we actually kind of need it. Do we need this one as well? No, we don't need this one as well because... Or do we? Yeah, we need this macro here. We need this macro here. We need this one. Oops. Okay. So, my bad. Okay, so we're gonna get this working, and then I'll show you. Man. You think you know how to use macros, and then you don't. So define UR1 width, and I'm gonna put this over here. Oh wait, hold on. First of all, that's not saved. Cancel. Okay, whoa. We can't know if this code is correct if we didn't have if we didn't even have that file saved. We can't tell if I made a mistake or if, yeah, so this tab was red, so come on. Okay, maybe okay, cool. Okay, so if we go over here, right, this might not look like much, but this is verification that I'm getting the glyphs into the correct location within my texture memory. So this is like a 4, this is a 5, this is a 6, this is a 7. I can't even tell. Oh, here's E, F, D, E, F. So this is probably C, D, E, F, K, L, M, N, And then down here, we can see kind of like S, T, U, and V, right? So if we want to see where that texture is, that texture is being loaded from here. And you'll notice that here, it's kind of colorful, right? God damn it. Let's go open this with paint.net for a second so we can zoom into this a little bit further. Okay, so if we zoom into this, we can see kind of the glyph. And we had some unused space, right? So for right now, we just want, 0 through 9 and A through Z, right? And so I'm like, you know what? We want to make sure we have if we're using 8x8 glyphs, the smallest power of 2 texture we can use is 64 by 64. So we have this unused space, right? And we're like, okay, what are we going to use that unused space for? And I'm like, well, in woodworking, sometimes when you're woodworking, you will kind of like scribble in pencil. You write notes on the wood, right? And then those notes will be in a place that after you assemble your woodworking project, no one will ever see them, right? So I kind of went with, so that's kind of the analogy of what this is, right? So this part right here, this stuff in the white region is not actual data, it's just scribbling in the margins. So I know that at 1 hour and 13 minutes, in video number 181 is where I did something with this. So it says tau dex equals 0. Oh, so that's information as to where I am putting this block of pixels into texture memory. So I'm not specifying the location of where this is going in texture memory in terms of just pixels. I'm specifying it in terms of, well, I can show you that. So if we want to know where this is located in the texture, we can find that configuration. So in Tau Depot data, Tau Depot stands for Texture as Uniform Depot, being like Home Depot, right? And if we look through here, I believe we can find that information. I think it's in here, right? Well, we put it in a little diagram, actually. So we see UIR right here. So UIR is 0 here. And so this cell right here is where we're putting user interface rectangle glyphs, right? So this is a 128 by 128 pixel subsection, right? So this thing that says tau dex equals 0, that 0 is this cell number 0 right here. And then within here, we have another section of 4 by 4 cells. And it's not written in here, but basically, since each one of these cells is 32 by 32, we have to somehow allocate 64 by 64 pixels. So we're going to say that we're going to select this cell and this cell to draw a rectangular region by selecting the cells. And so the rectangular region, if we do a selection rectangle that covers this cell and this cell, then we get all of these cells, right? And so, where is that defined? Is it defined in here? I don't even know where that's defined. It may be in here, it may not be. Through here. Might not be in this file. Oh, wait, no. User interface, no, this is different. I can actually find the variable name, though, because I know what it's called. So it's called, like, sub000, and there's sub001. And if we do a find in files really quick, we can find that. I know this is kind of, like, craziness, and, like, it's probably not making any sense, but, oh, well. I don't know, I'm crazy. I don't know what anyone expects of me here. Oh, yeah, so nice. We have this, like, diagram. So this diagram here is kind of a reimagining of what's inside of Tau Depot. So it's the same kind of diagrams. It's the same diagrams explaining the same kind of data layout, but it's kind of specific to the actual case for this data here. So if I want to know where this is being put in the texture memory, well, we're taking these two cells here, cells 0 and 5 to create this selection rectangle, right? Because each one of these cells is 32 by 32. So creating a selection rectangle here gets us a 64 by 64. And this 64 by 64 is in this spot right here, because tau dex equals 0. So the tau dex 0 here, and within this 128 by 128 cell, we're going to paste the 64 by 64 glyph set over here on my right monitor. We're going to paste it right in here, right? So it's kind of like overly structured, but my hypothesis, I have crazy hypotheses here. My hypothesis is that the more rigidly structured your code is, the less things that are going to go wrong. For example, maybe this is a little bit dogmatic, but I think that having very strict compiler settings usually prevents you from making a lot of stupid mistakes and pulling your hair out later, right? So I think that same strictness can be applied to the structure of your code. So I'm saying that, yes, this is kind of like crazy, rigid, crazy structured code in terms of like having all these various specific data layouts and dividing everything into these cells and making everything a power of 2. But I think that it's going to help prevent problems in the future, right? Because and I won't know until months later, really, right? So it's just very important that I can find my way around the code base, right? Because the code base is just going to get larger and larger and larger. You're going to forget what's in it, and hopefully you can come back to the code a month later, 3 months later, 6 months later, a year later, and navigate your way around places and find what you're looking for, right? If you can't find what you're looking for, then you've got a problem. So there's no way you're going to remember everything in the code base, so try to structure the code base in a way where you can find your way around. You might look at this code and say, well, this is crazy, I can't find my way around. I apologize. I tried to write it in a way where it's terse and where I can find my way around, but yeah, it's crazy code. It's crazy code. Yeah, it's crazy. And I'm going to drink more caffeine. Okay. So that's working. What's the next step? So the next step is, now that we have this kind of glyph set, and do you want to clean this up before we'll clean it up later. We'll clean that up later. Working code is the first priority. Cleanliness is a second priority. It's a pretty high priority, but it's not a main priority here. So we need to look at this thing called Uifrags. So in Uifrags is where we're going to create the fragment shaders for the user interface code for the different editors, right? So we only have one editor in these. Well, we actually have two editors, but there's only one editor that has a user interface, right? So this PAINT5D subsystem right here is an editor, and we need to create some user interface fragment shader code and then reference it within the fragment shader code for the PAINT5D system. Okay, so first of all, let's go open up the Uifrags and try to figure out where we need to put code. So here's the function file for Uifrags. Here's the data file. Okay, well, data file, there's really nothing in here, and you know, there may not be anything in here. We just have a structure where we have all subsystems are divided into data files and function files. So it's kind of similar to how a lot of people, when they write C code or C++ code, will divide everything into header files and implementation files. I do something similar, but I say I have a data file and I have a function file, right? So functions depend on data, so all of the data files are included before all of the function files to avoid artificial dependency loops. Okay, so this looks like just some boilerplate code. There's no initialization code, that's why this is called init none right here. I think that's good as that is. This is good as is, but we need to make some more files. And I don't know exactly how we're going to do this or what we're going to name them. But I do like to stick to the flat is better than nested. So we're going to just say, we're going to go right here and we're going to save this as, we'll save this as, we could put this in a folder here. Well, there's going to be a lot of them, so maybe we want actually let's make a folder, right? So new and folder, and we'll call this Uifrags default shaders. We'll call it Uifrags default shaders, and then in here we'll call this one do you want to call it, I don't know what we want to call it. Okay, well, you know what? When in doubt, let's namespace it out as verbosely as possible, I guess. So we can call it like AAC 2020. Well, let's not go that far. Let's PAINT5D, but it's not PAINT5D, right? It's all within Uifrags. So Uifrags PAINT5D, something like that, right? I don't know. Uifrags PAINT5D shader, right? Sure, why not? And let's go open up, let's try to keep the same structure as our other code. So if we look in here, we can look at like FragBed default shaders, PAINT5D default shaders, GPU. This is the last kind of default shaders thing I did, so I kind of look at the structure and see kind of how that's done. Yeah, so I kind of see how that's done. We're going to just steal that. We're going to steal that because that's a good starting point. And we see AAC, GPU view, default. So let's call this like, why don't we just say AAC Uifrags PAINT5D, right? So the idea is that this is Uifrags underscore PAINT5D, and this also has Uifrags underscore PAINT5D. So we can see the connection between the file name and what's inside of it, right? So the idea is we want to structure our code in a way where we can kind of easily connect the dots, if that makes sense. Okay, so in here, that's the file name. This needs to change though, and we could just give it. We could just name this section this, I guess. Okay. And this is the common fragment shader code. This is the GPU view fragment shader code. Is that how we want to assemble this? Oh, okay, no, that's not how we want to do it. So what we're going to do is, I see, okay, I see, it's coming together. We're going to say Uifrags. Do you want to say dot, or do you want to say... Well, we have a Uifrags underscore PAINT5D. That is quite the verbose kind of name here. So uifrags.paint5d.fra. Fra stands for like fragment shader. We could do something like that. And then we have to know, well, where is this coming from? So where is this kind of... First of all, we don't have this. So let's go make that. So in here, this thing right here is going to be here at this level. Uifrags.paint5d.fragment shader. Or do we want .fragment shader .paint5d? Well, we want a general to specific kind of pattern. So let's change that around and say .fragment .paint5d. I don't know. I do like general to specific, that's for sure. Yeah, why not we, sure, I don't know. I don't know what we want to call it. Something like that. So this thing here, so we're saying that instead of this, actually uifrags.paint5d.fragment.string, fragment.string, change my mind. Keep on changing my mind here. I do like to keep things in a general to specific order, but the .fra is kind of like a .frag extension, right? Now, I don't actually use file extensions, right? All the extensions in all this code is just ._, right? But kind of having this part at the end kind of like makes it feel like .fragment shader, right? And then when we're looking for, right, this is namespace, right? uifrags.paint5d. Right? Sure, something like that makes more sense, I think. And then it's already referenced in here, uifrags.paint5d.frag.string. So you see this .string here? Where's that coming from? Well, that is coming from the build script. And it's not in the build script yet, so we got to go add that. So in our build script, where are you, build script? This thing right here. We have some processes here, some pre-processing. Create build system executables. This is where we create the PNG hex dumper executable, fexdum.exe. Okay, generate hard-coded assets. So this is where like we embed those different PNG files so that we can get them into the texture memory. Okay, optional. Delete old shaders from the mod folder. So deleting GPU view and deleting Paint5D right now with the rm command. So remove, rm, remove, right? Because this is git bash code. Okay, generate GLSL code from C99 code. That sounds suspicious. Oh, hey, look at that. .fragment .string. Excellent. So that looks like the right place, right? This looks like what we need. Now, the exact order of this does not matter, right? It doesn't matter, but we should probably do things in order, in the same order as the library chain, just for consistency. So the insertion point would be around here. So this would be uirex.paint5d, because it's the Paint5D system. .fragment.string, and we're going to use uirex. We're going to take this. This is our input, right? In for input, which is this fragment shader code, which is this file right here. And the output file is going to be kind of the exact same name, except we're going to append this .string to it. And all we're going to do is we're going to use the awk command. We're going to ignore files that, sorry, not ignore files. We're going to ignore lines that are empty. And then within the curly braces is where our command is, the command that we're going to run on each line of the file. And all we're going to do is we're going to kind of print. So you could think of print as kind of echoing. We're going to print to the output file. All right, so we're piping from input to output here. Now this is kind of hard to visualize here because all of the escape sequences, right? But this $0 is the actual contents of the line, and then on each side of it we're just wrapping it in double quotes and then also adding a new line character, right? But the new line character itself is an escape sequence, so we have to like double escape it. So it's like, oh, this is all nonsense. Like I cannot mentally parse this. I just kind of remember what I did. You just have to remember, hey, we're wrapping the stuff, we're wrapping the source file in a big gigantic string, right? That's all you have to really remember about this. Okay, so we have this here. We got to start writing some code. Before we start writing, what do we need to do? Well, we need to kind of get kind of a rig setup that's going to make our this code that we're going to write in this file needs to compile both as GLSL code and as C99 code. So with that said, we have to have some type of rig in place for this to work. So not over here. Should we close this? Yeah, let's close this. This thing? Yeah, let's close this thing. PAINT5D.f. Sure. Yes, let's close this for now. Let's go look at like one of the fragment shaders. Maybe GPU view, since it's the last thing we worked on. Or is it? This is the last thing we worked on. Let's not worry too much about that. Let's just pick something and paste it. So we kind of have this big, we have a very ridiculous prologue of macros here, right? So if it's OpenGL code, all these macros here are going to be the correct things for getting it to run as GLSL code, right? And otherwise, if it is not GLSL code, if it's not OpenGL code, then we're running it as C99/C11 code. And all these macros here need to resolve to C99 types, or if they are referencing functions, or or GLSL types that don't exist in C99 code as primitives, then we need to use polyfills. So poly-OGL is the namespace for OpenGL polyfills, right? So to get polyfills so that it's basically C99 code that pretends it's GLSL code, if that makes any sense. It's polyfills in the sense of, if you've written JavaScript, I'm using it in that sense. Yeah, so this is just kind of ridiculous, kind of really heavy kind of prologue, right? So this is our shim ifdef macro section. Okay, so what we're gonna do here is, here's what we're gonna do. Let's just take all of it. Let's take the whole thing, paste it. We'll paste it and then we'll gut it, right? So we'll go over here. We'll take this code that we already know works. We'll paste it right here, and then we're going to gut it, right? So the first thing we're going to gut is all of the functionality in here. We're just going to completely gut it, right? So all this, well, actually not completely gut it, because you know what? The main function we should probably keep. So this looks like the main function. So frag color, let's keep this frag color call right here, and let's try to gut everything else. So just gut all of this, right? And we don't want to gut that stuff, though. This we can gut. Okay. So frag color, that's good. If this is not GLSL code, then we have to declare frag color. Otherwise, frag color is a uniform, and it's declared at the top of our GLSL file. Okay, so frag color, and then we have this UVec, whatever the heck, but we no longer have that. So within here, we're just going to say, to make a float 32, we're taking... Actually, let's not even do that. It's a float 32 that we need. Let's reduce some of this. Just bam, right? Make it dead simple, right? We're just kind of gutting it to get ready to add some code to it. But the first thing is we just want kind of like a stub that's going to do what we need it to do. So the next thing is paste into file. Well, this is going to be pasted into the file Uifrags .paint5D, right? This is going to be pasted here, right? So you can see that we're pasting it right here. So we're basically, so we used to manually before we made this build system, we actually literally had to take this code, copy it all, paste it directly into here, and then use column selection to surround it in double quotes, and it was annoying, and it took a lot of time. So we made this kind of build system to alleviate that. So instead of manually pasting, we can paste by using includes like this. So the build script will stringify these things and make a .string file, and then the includes will effectively do that cutting and pasting that we're doing manually before. Okay, so we can still keep the same note though, right? But instead of this here, we're going to cut and paste into Uifrags underscore PAINT5D dot underscore. Is that the best name convention? Probably not, but let's just go with it for now. Okay, and then we'll have to kind of clean this up a bit, right? So this is a bit clunkier, a bit more verbose of a name, so we have to kind of change that. And also, hold on, what the heck? We seem to have introduced an extra. Okay, there we go. Okay, so the next thing is, wherever we see this P5D001, we need to change this. So we see P5D001 AAC 2020. I don't even know what this commentary means anymore. Well, you know what? We can just nuke it, right? If we don't know what it means, we can nuke it for now, right? Let's just nuke it. It's just a comment anyways. So this thing, AAC 2020 PAINT5D default 001. Is that referring to actually this thing? I don't know. Let's just not. Let's just get rid of that as well, right? It's just a whole bunch of clutter. If we don't know what it was supposed to signify, right? We're just kind of adding these little comments to help us connect the dots in the code, but if we don't know what it is right now, we'll just rip it out, right? Because this uifrags.paint5d paste into this file here is helpful. But everything else kind of didn't seem very helpful. Okay, so now that we've done that, the next thing we want to do is kind of like these kind of comments here. We want to just get rid of, right? So, do we want to get rid of them completely? Well, you know what we can do? Here, let's do this. Let's make this more terse, and we'll just make a commentary here, and we'll say hashtag about ES macros. So we'll make a little hashtag about ES macros. Right, so we're going to get rid of that big block comment, right? We have that big, crazy block comment, and we're going to replace it with just this one line, about ES macros, right? And then what we're going to do is we're going to, we'll take this, we'll go into our documentation. So here's our main documentation file. It's just a big stream of consciousness. And we'll paste this here. And hashtag comments are off-boarded comments, which means a hashtag comment literally means there used to be a block comment here, but I took that block comment and I pasted it into this file, and I left a little crumb trail to let me know where to find the comment, right? So the idea is that the last thing people are ever going to look at is the comments, and because the last thing people are ever going to look at is the comments after everything else has failed them, we might as well not clutter people's code up with comments, right? We can just leave a hint that, oh, if you want to read the comments, well, they're over in this file, because I know you're not going to read the comments anyways, so if you're not going to read the comments right away anyways, we might as well kind of offboard them over here and make them a little bit less accessible, right? Okay, so these macros here, what are they about? So let's start to explain it, but let's also make a note of what the current video integer ID is. So we're on video number 183, and the time is currently 2 hours, 24 minutes, and, oh, we just missed it. Let's do a power of 2 there, 32. Okay. So this macro here, this set of macros, this pair of macros, all it is it's an air string macro. And it's used to create a quoted string without using quote marks, right? Because we're going to take all of this code and stringify it by like just wrapping it in double quotes. Because we're doing that, this entire file, nowhere in this file can there be a double quote. There should be no double quotes anywhere in this file. Now, the problem happens is that, well, what if we have a piece of code that needs to be written with a double quote? For example, an error message. Okay, well, the way we're going to fix that is we're going to create a little macro here, and it's going to use the stringification preprocessor directive. So one little hashtag here on the formal parameter of the macro function will convert the input to a quoted string. So whatever value gets piped into here, if we use this stringification macro, it'll paste the literal parameter name that was pasted in here, but it will also surround it with quotes. So you might wonder, like, why is there ES and ES private? And I don't know how, like, the preprocessor evaluates things, but for the preprocessor to accurately, for the preprocessor to do what I wanted to do, we have to have this extra indirection. I don't remember why it is, I just know that this is the way it is. We need these two levels. So here's our ES macro, and we need this. I don't know why. I don't know why it is. It has something to do with how the preprocessor works. But the really only thing you need to know here is that this stands for air string, and this is literally a quoted string. So if we want to do a use case of how that works, well, we can find it in the GPU view. I believe we might have it in here used somewhere. So if we look for ES, it doesn't actually look like we're using it here, so I'll just show you how that works, right? So it's pretty basic. So instead of something like error and some air string, instead of this, we can write so instead of this, what we can write is ERR and then ES, and then we can write this, right? So we can write, so it's effectively the same exact code, but no double quotes appear in the source. So with this air string macro, we can get rid of these double quotes, right? And then we can, our pre-processing stuff that kind of wraps everything in a big string will kind of work out, right? Okay, so with that said, that's explained. We can close this, we can move on, right? About ES macros, which is right here. Okay, so we got some more just cleaning up. You just want to go through here and make sure that... Now, we've already kind of like branched the GPU view shader, right? So we're pretty certain that all these macros are correct. Now, the thing is that if these macros are incorrect, if we make any little mistake with these macros, we could create some very hard to find bugs in our code. So it might be worth it just to go over this while we're here. So F32 is a float, U32 is a uint, int32 is an int, intvec2 is a ivec2, uvec4 is a uvec4, tf is for textile fetch, tau is for the tau depot memory, P5D is for the PAINT5D memory. So these are texture samplers that are always linked to the respective textures that are named Tau, Depot, and PAINT5D. SAM is when it is a U sampler, right? UFF is just because using unsigned integers in GLSL code can be very annoying. So this is just a uint FF, right? So the uint of hex FF. So U00 is uint of 0. I00 is an int of 0, right? So uint versus int. U03 is just a uint 3. B3 is just another way to say uint 3 for some reason. B11, uint 3. So there's a lot of things in here that we could probably remove because it's like we could, but let's not worry about hacking down these macros and making this list shorter. Let's wait until we've finished the shader code before we start to clean stuff up and remove, unneeded macros. In fact, I don't think I actually want to clean up this prologue of macros until months have gone by and we have not made any changes, right? Because it's just a pain to get all these macros in place and make sure that they're absolutely correct. So it's worth it not to remove these for now. So H55 is hex 55. So hex is usually an unsigned integer, so a uint 0x55. VA, I have no clue what that is, so we could look at that over here. VA is void, okay? So, VA, void argument, got it, okay? FE4, float vec4, is just vec4. So in GLSL code, it's implicitly float if the type is not defined. So the default assumption in GLSL code is that you are working with floats. So if you don't see a type specification, right, this is, uint, if you don't see any type of type specification, just assume float for these vectors. So ASS for assert. You cannot have asserts in GLSL code, therefore this macro evaluates to nothing. Error, well, we can't throw errors in our GLSL code either, so this macro evaluates to nothing. And then TRU is for trunk, okay? So if we look at, for example, assert and error, if we look at the same macro names when we're running as C99 code, you'll see that assert turns into an actual assert function and error turns into this halting function. Hey, that's actually wrong. We need to call, this is in Uifrags now, so we want to call the Uifrags halt function. And then we stole this from GPU view, didn't we? We stole it from here. So this is actually wrong here. This error message, this is the wrong error macro, right? We're inside of GPU view right now, not inside of P5D10GL. So this error macro should be this error function, GPU view halt. Okay, so we found a bug. Yay. Now, that bug was kind of inconsequential to the correct execution of our code, but our code is now more correct, right? Because it would kind of suck to throw an error, and the error message says that the error is coming from one system when it is in fact coming from another system, right? Okay, cool. So we reviewed it, and look, we found a problem. Awesome. Okay, cool. What else do we want to look at? So I think we might want to look at some of the things that are kind of tricky looking. So what looks tricky in here? So Texel Fetch, Tau Depot, PAINT5D, and uSampler. Let's look at those for a second. Texel Fetch is a polyfill for Texel Fetch. Tau is assigned integer 0 because it is editor number 0. PAINT5D is assigned a 1 because it is editor number 1. And so we're trying to keep a one-to-one relationship between everything to make it very easy to wrap our head around. So Tau is used for editor number 0, and it uses texture slot 0 And I believe it also uses texture handle 0, unless texture handles are probably generated by OpenGL, so we can't control what that number is. But if we can control what that number is, it's going to be a 0, right? And then for the PAINT5D texture memory and the PAINT5D texture sampler, all of those values are going to be 1 because it is editor number 1, right? So we want to keep this 1-to-1-to-1 relationship between all of those different values that it could be, but just because there's less to memorize, right? There's less to memorize. There was a very good programming teacher at DigiPen who had said a lot that, what did he say? Consistent habit. Let me not stutter while I say this. Consistent habits are better than a good memory. Consistent habits are better than a good memory. So that's a general rule of thumb. Now, if you have an eidentic photographic memory, feel free to disregard that rule. But maybe not, because maybe you're working on a team and other people who don't have photographic memories need the code base to be consistent, right? Okay, so that looks good. What are the other kind of things that kind of catch my eye where maybe we should make sure that they're correct? Let's just look at these. Let's spot check these ones and make sure they're correct. So we already know that these are correct here. Let's just make sure that they're correct over here. So these don't have any typecasts here because they don't need them in the C99 code. That's fine. This is still a 55 in hex. This is binary 1-1. That's why it's a 3. This is... Why is this B3? I don't know why that's B3. We'll just keep it that way, and then we'll probably delete it later. U03, UN... Yeah, that's fine. UFF, U00. Okay, that's all good. That's all good. I'm satisfied. I'm satisfied. We spot checked it. We found one little bug here. Also, let's make sure that this is defined, right? So if we go into the Uifrags functions, do we have that function in here? And yes, we do. Excellent. Okay, so what about these macros? I'm kind of sick of this, but let's spot check it really quick. Float vec4, int vec2, u32 is a uint, i32, float 32, binary 1-1 is a 3, a type. So this is probably some fancy macro magic to make the main entry point work in C99 code and GLSL code, which was a little bit trickier. So, so it's nothing if it's GLSL code, and then if it's C99 code, the type is a float vec4, and the input of the parameter is just called FC. That's weird. Okay, let's go look at that really quick. So let's clear our token highlighting and just look at where this is coming from, because this looks kind of wonky. But it'll probably make sense once you see where it's used. Oh yeah, so here's, yeah, so this is just our main entry point. And we want to be able to actually eventually test, oh god, there goes my bit width. There goes my band bit rate again. I hear people getting up. Okay, anyways, I'm just gonna keep on explaining because so I'm going to keep on explaining anyways, as if I wasn't breaking up right now, horribly. because I use these I create video archives of what I'm doing for later. So, oh well, I guess. And this is infuriating. Yeah, so this looks correct, right? So the main function when it's GLSL code doesn't take any parameters, right? It's just like, well, we can go look at what that is. So let's color code these for a second. So the function main, so ret main and function main, let's go look at those. So ret main is void, and the name is main, if it's GLSL code, right? So void main, right? Now, we can't do that if it's C99 code, because we already have a main function, right? We have the main entry point to our executable. So we have to give it a slightly different name, and that name is wrong. Cool, so we found another mistake. So it's not GPU view main, it is going to be a Uifrags PAINT5D main. Oh boy, that's a big name there. But that is a bit wordy. It's a bit wordy, but that's kind of the name we need, because it's kind of triple. So I usually double namespace everything, and this is triply namespaced. But that's just kind of the nature of this library, right? So this is the project namespace, this is the subsystem namespace, and this is the shader, right? So this is a collection of fragment shaders, and this is the fragment shader for the UI for the PAINT5D editor, right? So a big kind of clunky name, but our highest priority, well, actually not our highest priority, maybe our second highest priority is being able to find our way around the code base and understand and comprehend. We want to understand and comprehend the code and be able to follow our way around the code, right? So the understandability of the code is like our second priority, right? The first priority is working code, right? If the code doesn't work, nothing else matters. Now you could say, well, if we understand the code, then it would work. Not necessarily, I don't think. We could understand what our intention is, but that doesn't mean that it necessarily will compile. Right? Or maybe we write code that should compile, but there's some type of bug in the language, or in your graphics card, or there could be like just weird esoteric bugs that you might come across, right? And so you might have to code around those bugs. So yeah, I think first priority, working code. Everything else is a priority after that. I always change my mind on what second priority is. First priority is definitely working code. Understandable code. Rigid, non-abstract code, which I guess rigid non-abstract code is the same thing as understandable code. And then flexibility is not a priority. Flexibility of the code, well, I guess flexibility, I do like flexibility, but it's a very, very low priority, right? So we kind of intentionally write the code very rigidly so that we can understand the code better, right? The less abstraction, the easier it is to comprehend it. We want to be as dead, stupid, simple as we can. Okay, so that looks good here. Do we have anything else we want to look at? Oh, wait. Crap. Oh, man. Okay, now I'm scared. What's all this doing here? Did we not gut this yet? Did we not gut this yet? Oh, God. Please don't tell me that I gutted the wrong function, the wrong thing here. Did I not? Did I gut this? Did I screw this up? Did I totally? I can do a git. No, that's good. No, all this code's here. All this code's still here. Okay, cool. Okay, no, we're good. I could just do a git. I think it's what, git unstage. Okay, so we're looking at the parameter list. We're looking at all our kind of prologue macros. They look good. We fixed some bugs in them. So now we're going to go through this shader, and we're going to nuke some things. Oh, we were trying to nuke some things, then we realized we were going to nuke the main entry point function, and so we backed off for a little bit because we were kind of making mistakes. So yeah, this is going to be nuked. This function right here, nuke it. This GPU view get resolution width. Yeah, let's nuke this as well. Really, this should kind of be in a common fragment shader code. This should be like in fragcom, right? Do we have, so let's go look at fragcom for a second. Because that's generic enough where it should be in kind of like a fragment shader common code. But maybe there's the possibility that we don't have that. So if we look at this for a second, let's go take this name here, right? Get res width, resolution width, and let's go look at this for a second and see if no, it's not in here. And we can see, what are we doing? Well, we're just kind of wrapping eye resolution, and then we're wrapping. Oh, I see. So no, there's still not an excuse for that. This is just kind of unnecessary. This is unnecessary bloat. So we're going to take this. I'm going to copy that. And we're going to go into Fragment Shader Common Code, because this should kind of belong in Fragment Shader Common Code. We're going to look over this really quick. We got this fragcom rectangle thingy. We got these other floor, sealer floor, sealer floor. And then we have some kind of more complicated mapping functions. Texel fetch. So, assuming there's no kind of interlaced dependencies here, we could put this at the top or bottom. It doesn't really matter where we put it. But we would like this after any of the struct declarations, right? So we're going to paste this in here. We're going to paste that right there. And we're going to rename this, right? So not, instead of, right now this is inside of the fragcom section, right? So we're going to rename this and just say fragcom get resolution width, fragcom get resolution height. Yeah, that should be fine. And now that we have that, we may want to make a note of when we pasted this. So we might want to make a note like label this as @vidIID and label it as 247 and 32, right? So, ooh, that's not the video ID. The video ID, this is where I think I need some sleep, because I've been going at this for quite a while. 183, the video ID is 183, but the timestamp was this, but now we've kind of moved on. So it's going to be about 48 by the time we get this kind of going here. So let's call that 48, call that good. And let's just kind of, I don't know. Let's keep this kind of same section divider style. And then let's go down here, and this is where the section ends, right? So it's just like, if we want to know when we cut and paste this code, we have kind of this commentary section to help us out. Okay? So now we are changing a little bit too many things at the same. We want to change a little bit of code, compile, change a little bit of code, compile, because we don't want to make a whole bunch of horrible mistakes and have all the mistakes compound in such a way that it makes it almost impossible to recover from, or very difficult to recover from. So if you have a whole bunch of compounding mistakes, then things can be very difficult to debug and fix. So we're editing too much code, but I know that I'm in the danger zone with what I'm doing. And knowing is kind of half the battle, right? Because if you know you're doing something very dangerous, you can be more careful. You can slow down and say, hey, I gotta be more careful. Okay, so this is the PAINT5D fragment shader for the, this is the user interface PAINT5D shader. So these kind of functions here, we're gonna nuke these out of here, and I don't think they're referenced anywhere in here, are they? No, they're not. Okay, so we're going to, well, you know what we're actually gonna do? We're gonna make stubs. We're gonna make a stub, and we're gonna say, frag_com get res width, right? So we'll just make a stub of this, right? So, and it's not GPU view. This isn't even the correct name anymore. Frag_com get res height, and this is Uifrags. Okay, so if we kind of like search for this and we don't find what we're looking for, well, that's because you searched for the wrong thing. So, you know, this is not the, this right here is not the function we wanted, but it's the function we needed if we search for this. Okay, so that's good. What else do we need to do before this is all kind of cleaned up and ready to go? Well, this is kind of like ridiculous over here, is it? We got this like RY512. We made this kind of whole helper function, and then we're not even using it here. Okay, well, let's not worry about the fact that the code sucks. Let's just make sure that it runs, right? Everything is kind of, we've done a decent amount of cleanup. It looks kind of ready to run. We're not really going to see anything, so we might as well kind of make this 0.0 and 0.0 so that we can see kind of like a colored screen of some sort, right? We can make it kind of, let's make it orange. So red, so red and green would make it yellow, so I believe this is orange. I always get that confused because red and green making yellow is so kind of confusing. But okay, if we're going from red to yellow, or yeah, red to, as this goes higher and higher and higher, it gets closer and closer to yellow, right? So that means that if we make this lower and lower and lower, it gets closer and closer to red. So we go from red to yellow when we go from 0 to 255 here, right? So between red and yellow is orange. Okay, yes, yeah, so that is definitely orange. So okay, so we're just gonna make the screen orange just to make sure that works. The other thing is that this default shader thing is not quite correct again, right? This is more like a helper function that's going to be called, right? So, I mean, we could keep it as, no, we can't. This is wrong. So, this is a helper, this main function is a helper function, and therefore it's not going to be void whatever the heck. Well, actually, no, maybe it is. No, well, hold on. Let's go look at this again. Let's go look at function main and look at the signature. So void main, yeah, that cannot be the name in, that can't be the name. Not in this code. FloatVec4 is the final pixel color, right? FloatVec4, because the frag color is a FloatVec4, right? Yes. So, what we're gonna do here is unlike the other code where it's different, it's actually not supposed to be called directly. It's not a top-level function because it's like the UI code for a certain shader. So instead of doing this, it can just be the same exact function name, I think. I think that would probably be the easiest way. But if that's the case, then we don't even need this kind of switch here anymore, right? So these things here, if we see any of these, we can just remove them altogether, right? So we can just say float vec4, right, main, and then what are these types here? What are these taking? Now, I don't think it's gonna take anything. Let me think about it. Oh no, it needs the fragment coordinate. And if we see this, we see kind of this struct, this float vec4, which is a fragment coordinate. That's what the FC is. It's a frag chord. Okay, so in here, this needs to be changed around a bit. So we're going to keep these things here, but we'll keep this. This can still be this can still be FC, I guess. Yeah, this can still be FC for frag chord, but the type is going to be a float vec4. So we can see a float vec4. So float vec4. It should just be FV4 vec4, right? Float vec4. So it's not, yeah, it's not a top-level function. My bad. We can still give it, okay, so here's the type of the fragment coordinate. Here's the input frag coordinate. Okay. Now, when it's C99 code, the type is a polyfill, because we don't have a float vec as a primitive. And it's still going to be called FC. Okay, so now let's go look at this code here again. We got the, so in this GLSL C99 code, it's the same, right? Well, it's not the same, it's a little bit different now. It's a vec4. It's a vec4 if it's GLSL code. This part is a vec4. And this right here, it's going to be called FC. Either way, it's called FC in this case, here in this code. 1, 2, 3, 4. Okay, so that means that I believe somewhere in here we did some weird stuff where it may have, no, frag color, blah blah blah. So let's just put a no op in here really quick, because otherwise this won't compile. So if, actually we can do that if it's, if this is OpenGL, and then otherwise, you know, if fc, fragment core dot frag core dot x, or frag chord dot y, and just do no op. Right, so we just need a no op here to stop the compiler from being all like, hey, we see we didn't use those variables, so we're gonna crash on you. Which I told it to do that, but sometimes I want to ignore that. So I'm just kind of circumventing my compiler from warning and crashing, right? So warnings are errors in my compiler, so in the way I set it up. So I use a flag called werr, which means warnings are errors. Okay, so with this, right, not a main entry point like other frag shaders. Let's make that terse. Not main entry point. Well, frag shaders is a little bit redundant. They're all frag shaders. There's no other type of shader I've been writing, so not main entry point like other frag shaders. So that's just a comment so that we can kind of like know what we're doing here, and we might want to just we might want to highlight that a bit. So we might want to actually do this and just kind of scream it a little bit. Right, make that red. This is not a main entry point like the other shaders. It is the main function. It is the main function of this file, but it is not a main entry point. So the parameter types are slightly different than what they would be otherwise. Okay, sure, that's fine. Do we really want this kind of timestamp here? Because this is from another piece of stuff. I don't know. Let's just keep it for now. PolyOGL, I don't know why we have that. RY. Oh, because RY is... Oh, are we supposed to be able to use this? Or is there... resolution on the Y, 512. That is a little bit suspect. I'm suspicious of this. Well, let's go look at the PAINT5D shader for a second. The actual PAINT5D fragment shader. So if you do look at P5D. P5D10GL.fragment shader. Let's go look at how we get the resolution here in the main function. So we got some rendering code, some stuff that needs to be cleaned up. Okay, so here's our main kind of entry point function. And we see that RY is I resolution, and then 512. Hold on. If not defined. Okay, if it's not OpenGL code, we just assume that the viewport is 512. Okay, that's fine. And then RY is iResolution.y. Okay, now is that how we do it in this new code? So in the Uifrags PAINT5D.fragment. Hard-coded as this if it is not... So the NDEF is kind of easy to miss. Otherwise, RY is iResolution.y. Yeah, that's fine. Okay, that's fine. That's workable. Okay, so let's close this, because that looks good. Let's keep that open in case something happens with the compilation. And we're not actually using this anywhere, right? So if we get any errors, if we get any errors, then the problems are that we have incorrect C99 syntax. Anything we did in terms of the GLSL in this code here is not going to be detected yet. Well, not anything. If it's invalid C99 code, then it's invalid GLSL code. So some of the GLSL mistakes will be caught by my C compiler, my C99 compiler. Okay, let's just give it a run, right? We've made too many changes. Let's fix whatever mistakes we made, because I'm sure we've made some mistakes. And then after we have fixed whatever mistakes we made that are causing us not to compile, did not expect that. Cool, I guess. So it compiles. Okay. Yeah, okay, cool. But why does that compile? Oh, well, this file isn't included anywhere, is it? It's not included anywhere? No, I don't think so. I think it is. So, if we look at, well, no, it's not. So, okay, so if we go into Uifrags default shaders, right? We go in here, and we open up this file here, right? We can see this kind of code, and this code looks great. but where is this included? And the answer is nowhere. Right? It's not included anywhere in the project. So from here, we need to include these pieces of code, and we also need to include this file in the C99 code as well. We just need to include this code in the C99 code so that it can, just so that we can compile it as C99 code as well as GLSL code, so that we get the advantage of, if it is not valid C99, then it's not valid GLSL code. The other way around isn't quite true, but GLSL is based on C99 code. Now, well, that could be a blanket statement. That could be a blanket statement that's not quite true, but let me say that when I write my GLSL code, I'm trying to write it in such a dead simple way that what I'm saying is true, right? But maybe not, right? And now, and that's also the reason for these macros, right? So we're running as GLSL code, we have all these macros that are GLSL types, and then we're running as C99 code, we have all these types that are C99 types. Anyways, so let's go integrate this into our code base. So we already have it in our build system, right? So we see that we're going to take this fragment shader code and we're going to turn it into a big string, and we can already see that, right? So if we want to go see the result of that from our build process, if we go look for Uifrags, we notice that, oh hey, there's frag.string. Let's take a look at what that looks like. That is not what I expected. That's not good. Why is that blank? So Bash likes to, sometimes when Bash fails, it will just kind of not tell you. So let's kind of look at this for a second. Oh, yeah. Uifrags dot, that's wrong. Okay, I see the mistake. I'm being stupid. Okay, so let's go find Uifrags for a second. Uifrags. This thing is wrong. This thing. So first of all, let's delete this. Okay, do we want to delete this? Yes. Okay, so let's go look at our build script for a second. So uifrags.paint5d. Do we see any file open up that says uifrags.paint5d.fragment_shader? No, I see uifrags, right? uifragment_shaders.paint5d.fragment_shader. So this thing that says uifrags, that's wrong. That needs to be uifrags. Okay, so why don't we just give that a run so that we can assert that this string is going to be generated by our build system. So we might as well do that and right, take these little baby steps. Since our code is already compiling, it's not crashing on us, we might as well take some little baby steps. Since we already made these gigantic leaps and wrote way too much code all at once, and now we found ourselves in an advantageous position where we can start to take more baby steps. Okay, cool, that works still. Excellent. And now let's go look for that specific stringified file. So we're going to look for this file right here that's generated in our build script. So go over here, let's go open, and let's look for Uifrags. And hey, there's this file. Okay, that's a good sign. Now, does it have what we want in it? And yes, it does. Look at that. Excellent. Beautiful. Beautiful. Oh, this is ugly. But alright, this is beautiful. Now this is a disaster. It's a disaster, but we're never going to edit this file directly, so even if some of this is a complete disaster, it doesn't really matter. But you'll notice that since we're wrapping all of the stuff in a big, gigantic string, we can't have any double quotes in the source code. Otherwise, things will explode on us. And that is why we have these ES macros. So this ES macro stands for error string, right? So if we need to throw an error in our code, we have to use the error string macro to avoid having double quotes in the source. Now, GLSL code cannot throw errors, right? But remember, we're compiling both as GLSL code and as C99 code. So when it's compiled as C99 code, our assert macros and our air throwing macros will actually evaluate to valid C99 code, right? And then when we're compiling as GLSL code, the macros for the air function and the assert function will just be removed, right? So if you define a macro function and then don't give it a function body, it'll just, the preprocessor will just delete that line of code, which is kind of nice. Okay, so that looks good. What else do we need to do here? Okay, well, it's working. I mean, it's compiling. But we need to get some type of visual feedback. We need to get some visual feedback that, that this actually kind of works. So, where is this going to be called from? So I guess the important part would be, where is this called from? Oh, wait a second. Remember, this isn't being included anywhere. And we can kind of prove that. We can prove that. So, Uifrags, PAINT5D main, right? If we take this function name, copy that, and we try to call it from where we want to call it from. Let's put where we actually want to call it from. So we want to call it from this fragment shader. From this fragment shader, we would like to call that function, right? And we really want to call it when we're within the bounds of the user interface rectangle. But let's not worry about that part yet. Let's just worry about, hey, if we throw this into the main function, what happens to us? Nothing good is the answer. Okay, so right here, let's just pass it on down, right? So we not quite. So where's our fragment coordinate? Oh, where's the F? Where the heck is FC coming from? So somehow we have an FC getting in here. Oh crap! That's right. No. Okay, no, that's fine, that's fine. Okay, so we have this function, and it just takes FC, right? So this should be the correct data type, right? It should be a float vec4, and then FC is for frag chord, right? So the output right here, this should be a ivec4, invec4. Actually, no. Oh, FE4, right? FE4, right? So it's a frag color. User interface pixel, maybe? I don't know. UI rect 1 pix. Something like that. I don't know exactly what to call it. Something like that. Okay, so the thing is that this is not going to compile. It's going to say, hey, we don't know what this is what I'm assuming. So let's test that hypothesis right now. And then if we get the mistake that we think we're about to get, implicit declaration of a function, right? So that is correct. That is, I got the mistake I thought I was going to have. Okay, well, I'm not going to say that I thought I was going to get implicit declaration of function. I knew I was going to get something that was going to tell me that this function does not exist. Now, do I remember that it's called implicit declaration of function? I honestly don't know. Yeah, I don't know. I feel like, you tell me what implicit function... you tell me, if I see this, I know what it means, but I don't know if I could go the other way back, right? It's a one-way linked list in my brain, right? We go one-way link from this to what it means, but I don't know if I could go from what this means back to the error, right? I don't think I could. Okay, so anyways, let's go fix this. So, the first thing is, to fix this, we got to look at our build script. Well, actually, no, not our build script. Well, let's look at our build script really quick. Nope, because here we are compiling this C11 file. Ooh, we're compiling a C11 file. AAC 2020.C11. Could that have something to do with it? Yes, it does. Nothing else in here, though. Everything is kind of resolved in here, right? So we are successfully serializing the correct... Oh, sorry. We're successfully serializing the fragment shader code. That's good. So in this main C11 file, this is called Uifrags, right? So where is that? That is right here, right? And this is supposed to have fragment shader code for all of the different systems, right? Okay, that's cool. But how does that happen, right? Well, that happens in libchan, right? So let's go in libchan. And let's go into the top file. So you could think of this as a solve right here. This is the name of all of the different subsystems in the entire project. So this is basically a solved dependency graph. The exact order of all these does not matter, but certain things need to come before certain other things, right? So when you think of a dependency graph, a lot of times there's multiple ways to solve that dependency graph. I don't like that kind of uncertainty in my code, right? Like, I don't want to introduce another dependency and then the dependency graph is like wildly solved in a completely different way than it was solved before that dependency was introduced. So therefore, instead of having some type of dependency injection solution or kind of solving things by using includes with the include guards, we just kind of like front load everything in a very specific order. And this means that we have to have a complete detailed knowledge of our dependency graph, right? So mentally, I have kind of a dependency graph in my head of what depends on what, so I can basically manually solve the dependency graph. So this is right here is a manual solution of the dependency graph. But this is just the summary, right? So the actual implementation details of solving this dependency graph is within libchan top. Libchan stands for library chain, because I'm literally chaining all of the libraries together in a linear, consecutive kind of order here, right? So let's go look at libchan and see what we can find. Interesting. Okay, so some sequential numbery thingies. Okay. Oh, hey, this looks interesting. Silence, kill test, reentrant unit test runner, to-do manager. I think I recognize those names. Oh yeah, silence, kill test, reentrant unit test runner, to-do manager. So it's in the exact same order. It has the exact same numbers. Okay. So now that we're in here, what about Uifrags? What's going on there? So let's go look for Uifrags. Okay, so here's the data, and I have a question for myself. Is this shader code on my right monitor, is it function or is it data, right? Because it gets wrapped in a shader string, right? And then it gets put into a variable. So does that make it a function or does it make it data? Okay, well, we have to remember that we're compiling this code on the right monitor as C99 code, and we're compiling it as GLSL code. So we have this kind of ambiguity when we think of it as GLSL code, but when we think of it as C99 code, well then the answer is obvious. The right side of the screen is function, not data. Okay, so now that we know that answer, this is the data section, right? So this section right here is the .d file, right? So we're going to take this and we're going to go find the function section. So here's the function section, right? So it looks exactly the same. You may have not even seen me swap, right? So df, 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 etc., right? So in the function section, we want to include this shader code. Now, do we want to include this shader code before or after this? Well, this code here is going to contain any unit tests. So if we want to unit test this code on the right, then this code on the right needs to be included before this code so that this code here can reference this code for whatever unit test that it may need to run. So the answer to that question is before. So we're going to include, and then whatever the heck this is, right? So we're going to take this, wrong thing, I'm pointing at the wrong thing. Well, the same idea, but I was looking at the wrong thing. Okay, so right here, this was the, yeah. Same idea though, right? It's still fragment shader code, but I was looking at the wrong fragment shader code, but same idea. So pretend I didn't make that mistake. Okay, so we don't need this because it's all relative. We're already in the current folder that we need. So we can go current folder /, and then we can kind of try to line this up in a way that makes the most sense without going outside the boundaries. So maybe like this, right? So therefore, we see Uifrags right here. Yeah, I think that's the... God damn it, keep on hiccuping. So I think that's the best way to do this. And then we also want to make a note of this, that at pattern breaker. Okay. And then... So a lot of times when we're editing the library chain, we will kind of cut and paste code. But we don't want to accidentally kind of cut, paste this, and refactor it if it's a pattern breaker, right? So we want to be like, oh, wait a second, this is a pattern breaker. Maybe we want to take this one instead, because this kind of fits the pattern, right? This is a slightly altered from the pattern that we usually use. Okay, so that looks good to me. And then if we need other kind of shaders, like if we need a shader for a different editor, then we'll put the editor name here, right? So if we need a shader for another editor, we'll do another include, and then, you know, other editor name here, other editor name dot fragment shader, right? We'll do something like that. And so we'll keep a collection of all those. So let's just do that. I kind of like the visual space here, so let's kind of keep that visual space. We could, though, however, maybe... I don't know, just for the heck of it, so, I don't know. Just so that we can more easily see that this lines up. I don't know, maybe I'm just being crazy. I'm probably being crazy. Okay, so what else? So, by including this code, it's now going to be interpreted as C99 code. And it's going to be able to... So we're not going to get that implicit function declaration, right? So this is going to go away. But we may have made some mistakes in that code that are going to get caught by the compiler, by the C99 compiler right now. And error unused parameter, okay? So not too bad in the expansion of this macro, and that's fine. Excuse me. So let's go look at that code. Okay, so let's find the main entry point, which is all the way down at the bottom. Maybe I should just start at the bottom and went up rather than scroll down, because okay, so here's the main entry point. And remember, we're thinking of this code as C99 code right now. So it's saying that that FC is an unused parameter. So this FC. Well, that's kind of confusing because we got this thing here, and this is, you know, so it's right here, so it's being used. I would have expected a different error than that. Like, you know, how about this? This is an unused parameter. So uifrags.paint5d.fragment shader. Oh, we're on the wrong file. Wait, hold on. Uifrags paint5d main. Uifrags paint5d fragment shader. Now this is P5D10GL. This code has already been compiling, right? So the new error would have been introduced in here. Sometimes I just can't keep my head straight on what goes where. Okay, so it's saying that in here, this fragment coordinate value is not being used anywhere. And indeed, it's not. So how are we going to fix that? We could just say the red, we could just say, you know what, take the fragment coordinate is a float. So we could do like fragcord dot x divided by 255.0, right? We could do something like that and get kind of like a gradient from, yeah, we could do that, right? You could get like a little gradient. Sure, that should work. That should be enough to get rid of that warning. God damn it. So let's take that for a spin. Or not. Let's take this for a spin, and then once we get this code compiling again, we will, yeah, okay, so that's what I was expecting. I was expecting that this variable would not be used, right? I was looking at that, I'm like, how come this isn't, right? Okay, so it's kind of bouncing back and forth. That's okay. So, user interface 1 pixel, right? User interface rectangle pixel. Let's just say, we gotta use this somewhere. How about this function just returns like, ooh, no, that would be bad. Okay, let's not worry about it yet. Let's just say, okay, maybe we're gonna have to fix this. So we got this viewport, whatever the heck thing. Get variables stored in texture, right? We're gonna have to make a, we're gonna have to solve this right now. Okay. So, you know what? We'll just say, let's just get it solved. So we're gonna make another rectangle. Just cut and paste this for now. And this is gonna be called P5D user interface rectangle 1, right? UR1, aka P5D I don't know for sure. I don't think I have such a thing. Sure, why not, just in case. So So this thing is UR1, right? Look, it almost looks like URL, but user interface rectangle 1. And then we have this tau-frag, right? Tau-frag, which is kind of like a... Tau-frag is allowed to know about this, I believe, right? Let's make sure, though. So let's look at this and hope that we didn't make any stupid mistakes. So let's say Uifrags is here. Here's tau-frag. And here's UI... Oh, man. Okay. So that would be a no. Do we want to reconsider the ordering here? I kind of want to. So, well, hold on. Oh crap. Is Uifrags... Are we referencing Uifrags in Tau Depot? Because that would be wrong. According to the order we have. No, it's not being directly used here. Okay. Okay, I'm getting tired. I gotta take a break soon. So then what the heck does Uifrags do if Uifrags is there and we already have Tau Depot? Well, let's go look at Uifrags. Okay, so we got some functions and we got some data. Uifrags grabs a top-level Tau Depot slot for itself to make the connection obvious. Okay, so Uifrags needs to reference Tau Depot. Okay, cool. We have this kind of glyph stuff. Okay, so it's for pasting code into... It's for pasting the graphics into... It's for the actual pasting of the glyphs into the texture memory, but it's not actually for figuring out the locations. The actual locations are stored in Tau Depot, it looks like. Okay, so we can do that because it's yeah, okay. So P5D user interface rectangle 1, right? Okay, so we want to make a function for this. And so first thing we're going to do is we're just going to find a similar function. And we're going to open up tau-frag and go find it. So tau-frag. Tau-frag.frag. And go look for the name of this. Oh, there you are. And mini local function indexes. Let's just tack it on to the end, right? So 4 is this thing now, right? So we're going to add this, not this thing, P5D rec PAINT5D, and it's going to be Uirect1. Okay? And so to get that working, we can just steal this code here. We can steal this code. And we can go down here and we can just paste that. And then also, we might as well make a little divider line here. Okay. And then we just want to say, anywhere we see this kind of VP1 kind of stuff going on, we want to change that. We want to refactor that. So this is going to be Uirect1. UR1. UR1. It almost looks like a URL. So UR1. UR1. Right? Anywhere UR1. UR1. P5D UR1. P5D UR1 here as well. And then P5D UR1. Okay, so this is the actual... So we've used kind of uppercase and lowercase so we can connect the dots a little bit better. The lowercase is the actual rectangle object, where the uppercase is the actual location of that piece of data within the tau depot memory. Now, it's still going to be in tau 15, right? Because this is the just the rectangle that says where it is in the shader or in the editor. So this is good. Tau, PAINT5D, Uirect1. Now the thing is that this macro, if we look at one of these other macros, like P5D80, it's probably declared in this in here somewhere, right? Yeah, undef P5D80, right? So we have this kind of thing here. So we want to do the same kind of thing to here, right? So we have this like VD1. So let's cut out the ridiculous lowercase stuff. P5D UR1, and it's after VD1. So var UR1, and that should be 12. Okay. And then over here, we're going to do the same thing. So let's just duplicate this. And this is going to be UR1. And then this tau frag, tau sub, P5D, var, UR1. Okay. And let's just keep on looking around here. Places, oh god, maybe not what we want. Let's just look for this. Let's look for this because after it, we should always see a UR1. There's a UR1 underneath it. A UR1 underneath it. Okay. What about this capitalized? Like, let's just look for VD1. VD1, there's a UR1 underneath it. Except for here. Why is that? What's going on? What are we looking at here? So this is... tau frag, tau sub. It almost looks the same as the other code I was looking at. This is a define tau frag, tau sub, P5D var, UR1. So that's the define. And tau frag, tau sub. That's also defined. Do we have dex var? Have we kind of like copied this twice? Why does it look like we have this twice? Have we perhaps defined this when we should have undefined it? Tau frag tau sub P5D var. Tau frag tau sub. Oh, no. Okay, so here's where we're declaring the macro. But then over here we're assigning it. We're getting our left and rights mixed up. Okay, so over here, right, we want to, let's duplicate this, right? And so this is a macro that's kind of locally defined. And tau sub, so tau sub P5D var, and it's going to be, we're just going to call it Urec1, right? Well, I can kind of see why I would have made that. Let's not worry about that. So Urec1, and it is not 11. It's not an 11. It's a 12. And then Urec1 here. Urec1, okay. So the other thing is, where's our unit test, right? So we have a unit test for this. So let's go look at the unit test code. So Uifrags. Hold on. Tau frag, sorry, tau frag. So we look at tau frag. And we look at the fragment shader code, or not the fragment shader. If we look at here, we're going to have a unit test code. Very simple unit test, but it's a unit test. So this looks like the dex taus. Then over here we have the subdex, and then we have the variable indexes. And so you notice that right here is where we'll just copy this. We'll replace this one with var, and we're going to make this all capital. So we're going to go UI rect1, and that should be 12. And to make sure this works, right, I think this is the only point at which we have to insert that, right? So this is the unit test running code. To insert this, though, this number of variables is now one more. So 0 to 12 means there's 13 in terms of the number of variables. So if we go over here, this has to be a 13, right? Okay, so now that that is edited, let's go look at tau depot, right? So tau depot is kind of what's storing all this wire up stuff. Okay, and we should have kind of a list here. So here's 11. These don't have... I don't remember why, but this is flagged as do not define, right? Do not define this macro, do not define this macro, right? Or it's defined, but it's saying don't use this, don't use this. For whatever reason, I don't remember why. But then the next thing we want to use is this UI rect1. So it looks like we made this kind of lowercase, because this was probably lowercase, but now we changed our mind on that. So let's look for any case where we find UI rect1 like this, and let's just make them all capitals. So let's match the whole word, or match the case, and let's just find all really quick, and find all the sites where we screwed that up. Liar. Oh, you know what it is? Turn off match whole word. Okay, find all now. Okay, so all the offending locations, we're gonna just change this to UR1. Notice that that's 12, and that is the correct number. Then over here, we also have this. It needs to be UR1 as well. Let's just, I don't know. This is maybe I'm gonna change my mind on this for now. UR1. Over here is going to be a UR1 as well. UR1. Okay. So now the casing is consistent, and Tau Depot has this set. P5D UR1 is going to be set using this macro, where this macro is up here. Its value is set to 12. We added one more to the number of variables. We added the that entry to here, right? It's the 12th thing. This order does matter, right? It's not an arbitrary order because the index location in the array must actually match the values that we're inserting in here. Okay, what else are we screwing up? I am losing my mind here. Okay, so we're just going to... Well, hold on. Let's finish that filler function, because we didn't quite finish that. We were looking around, making sure everything was changed correctly. Get rect P5D UR1. Oh, so we want to make sure that this little macro is defined and undefined correctly, right? So here we're undefining it. That's good, so it's not going to leak into our other C99 code, or C99 files. At the top of the file, we define it, and we define it as this thing, and AAC 2020 tau frag tau sub. That's not what this is. This is Tau Depot sub PAINT5D. So this variable right here is just a copy because it was kind of hard to figure out a way to get this into the shader code. So we kind of have a hack. We just have a hack where to get this into the shader code, right? So this is the variable we want to get into the shader code. And the way we're going to get this variable number 12 into the shader code is we're just going to define it here as another variable. So this is a tau frag namespace variable. And then over here is a Tau Depot namespace variable. And you notice that they both have the same 12 here, right? So this kind of sucks. It's kind of ugly. The way we're going to alleviate or put a band-aid on this suckiness is we're going to just write a unit test, right? So we have that unit test for tau frag. So let's go open up taufrag.f again, right? So the unit test right here is just making sure that the Tau Depot version of the variable matches the tau frag version of the variable for these defines. So all these defines of the same names should match directly. So the D1 macro the VP0 macro for viewport 0, viewport 1, viewport canvas, the tile quadrant, the tile exponent, the tile layer, the brush X, the brush Y, the offset dex, the tile value, the viewport down 1, and the user interface rectangle number 1. All these defines need to be equivalent to each other. It is a ugly, ugly hack, but we wrote a unit test, so yay, it's ugly, but at least we have a unit test that's going to tell us when we screw up, as long as we make sure that we update the unit test as we kind of like do this, you know. So we might want to make a note of that, right? So at vid IID 0183, right? And the time is 03:44. I don't know. Let's just wait for 45, and then okay. Ugly, ugly hack. These defines have same values as AAC 2020 Tau Depot defines of the same name. All right, so oh, also this is shader code, so hold on, we have to change this. First of all, we can just say ugly hack rather than ugly, ugly hack. So 1, 2, 3, 4. So we're trying to make sure that we're kind of like off the margins here, because this code gets wrapped in a string, gets pre-processed so that we can inject it into our GLSL shader. So usually we go all the way up to this line here, but for this shader code, for this fragment shader code, we actually want to keep 4 spaces away from the line. Defines of, let's just remove the of same name, all right? We don't have to be completely perfect English, we just have to know what the heck we're talking about. There's one more thing that we want. Don't forget to update the unit test. Okay, so we have a unit test, right? So because these values directly match values over here in this subsystem, right? This subsystem has a whole bunch of variables, right? So you see TQ, TE, TL, right? And also we see the TQ, TE, and TL, right? 4, 5, and 6, and they're also 4, 5, and 6, right? They have to match exactly. So we don't want to forget to run the unit test. So we'll look at right here, tau frag, and look at what that unit test is called. And it's just called tau frag unit test, but specifically it's this, right? So don't forget to update the unit test, right? And this is the specific unit test name that we want to update. Okay, so we're going to make a, so there, we got a nice little note of what the heck this is all about. So, and we are being very verbose with our comments, but we can always subtract comments later. But a lot of we can't really add them after the fact. We gotta write the comments as we're thinking what we're thinking. We can always remove them later, but we cannot add them later, if that makes sense. We can't know what we were thinking a year ago and put that comment in the code, right? We gotta do that now. Okay, so let's go look at this UI rect whatever the thingy and kind of follow the trail. So here's P5D UI rect 1, which is going to be, we can see it right here, and then we can see it right here, AAC 2020 tau frag get rec. The rectangle name is P5D UI rect 1. And does it take a void argument? Yeah, it takes void, okay. And here's the rect called P5D UR1. Here's the location of that variable. That's good, okay. And then we undefine it at the bottom, right? Okay, cool. So that looks good to me. I'm satisfied that that's correct. The unit test, we can close that. So this is the PAINT5D fragment shader. And so here we're getting that rectangle, so P5D UI rect 1. So we get that rectangle, and now we just want to hack this a bit, right? So to hack this, we're just gonna say we're gonna take this, we're gonna copy this, and we're gonna say that so this is the fragment integer coordinate, right? So fic.x and fic.y, right? So we got all this crazy code, kind of figuring out what the frag color needs to be, right? And okay. If this is not OpenGL color, we have to return frag color. Okay. So let's just make a section here. Let's call this user interface draw user interface over whatever. I don't care anything. Okay. So if we do it like this, we're just doing this because we're lazy, but it could also mean that we can make the user interface transparent and see what's behind it. So it's not like it's not a completely lost cause. And so this rectangle right here, this is a rect. So if fic, right, fragment shader integer coordinate dot x is greater than or equal to this dot x0, and then let's make this a 1. So if 1 and, right, so the x is right, and fic.x is less than or equal to P5D Uirect1.x1, the upper bound. And then we want the same exact kind of code for the lower bound, right? So for the lower bound code, we're going to say fic.y. And then over here, we're going to make this fic.y. Okay, so if we're inside the bounds, okay, are we inside the user interface rectangle? That is the question that we want to know. Okay, let's not worry about that too much. So if we're inside the user interface rectangle, well, first of all, we have an unused variable, right? Way up here. Well, hold on. So this kind of main thingy-mabobber, whatever the heck, let's not put it here, right? So we don't actually, it doesn't really matter. We don't really want branches in our code anyways. Let's not worry about the branchingness of the code, right? That's kind of a little that's an optimization for a later date. But yes, branching code can be very bad in shaders because you get this thing called warp divergence, which is just a fancy way to say that the code is no longer as parallel as it should be. Okay. So floatvec4 user interface pixel, right? User interface rect1 pixel. Let's just call this Uirect1 pixel pixel color. Pixel RGBA. Sure. Some kind of comment that kind of lets me know what that is. Okay, so if we have this, and this is a floatvec4, right? Frag color should be a floatvec4 too, right? So yeah, let's say make floatvec4. So all we're going to do is say, for now, we're just going to say, you know what, if we're in here, we're just going to say, frag color equals user interface 1 pixel, because it's a float vec4, right? So we're just gonna stamp the user interface directly over, override the pixels that we're rendering. And now to do make UI transparent if needed. Alright, so we can make the UI transparent if it's needed, but we don't need to do that right now. We just need to get this working. Okay, so we got this thing, and that's cool and all. But, what's the code for this, though? Okay, so here's the main function. Hold on. Did we not change this, or did we break something else somewhere else? So this is Uifrags PAINT5D fragment shader, right? And it is not like, it's not like other pieces of code where this is like a top-level function. This is not a top-level function at all. So this is wrong. This is wrong. I think that I meant to get to it, and then I just didn't get to it. Oh, we made a note here, not a main entry point like other shaders. So we made a note here, but we did not... So we fixed some of this stuff, but we didn't fix all of it. So this thing right here, right? So this is the GLSL code. We're going to give it the exact same function name. Can it be void? Nope, it's going to also return a float vec4. But instead of fv4, right, we can use... the actual type, right? So instead of float vec4, struct polyfill, whatever the heck. Oh, I see. Okay, we might as well just say fv4. It's the same type. Okay. And so this is kind of a GLSL. And, sure, I mean, that's all nicely aligned. Okay, so there we go, that signature is all fixed up. Right, it's the same. Well, hold on. If ret main and fun main in here are the same, then we just don't need to use these at all. Right? Oh, I see, yeah. So if you look at ret main, it's not defined anywhere, right? Oh, well, it's... So that is there. That is air. Okay. Okay, yeah. Got ya. Not needed here. Not top level function. So no... ret main, right? It's not a top-level function, so no function main, right? Okay, so let's change our mind. Do we have enough room to do this? Just enough. Not top-level function, so... Let's just call it func. So now. That sounds kind of like some weird word. Yeah, so it's not top-level function, so we don't have a ret main or a function main anywhere. And then this right here, we undef something, but we don't actually need that, so let's get rid of it. So let's just say, oh, it's not a top-level function, therefore, no... Right, not top-level function, so no this thingy, right? That is kind of ugly. There we go. Sure, okay. What other kind of things do we need before we can compile this and try to get it running? Well, let's kind of look at the function for a second. and see what it does. So it doesn't actually do anything yet. It just kind of returns red, right? It turns like a red gradient. That's fine. That's fine. That's all we really need right now. It takes the fragment coordinate, and it does something with it, right? Yeah, that's fine, right? It just takes the fragment coordinate as its input parameter, and just does whatever it needs to do with it. Okay, cool. So in the PAINT5D fragment shader, here's where we're calling the Uifrags PAINT5D shader. So this is basically the user interface shader for the PAINT5D system, and it takes that fragment coordinate. Excellent. Then it gets back a UR1, so UI rectangle 1 pixel, right? A pixel color, which is it's a float vec4, right? Because frag color is in terms of float vec4s. And we're just gonna completely overwrite whatever we already rendered, right? So we're just gonna stamp the user interface directly over whatever was already rendered if we're inside of the bounds of the user interface. Woo! Okay. Let's give that a run. Let's give that a run, see if we have made any stupid mistakes, fix our stupid mistakes, just get it running, and see if we can eventually just get a block of like solid red, orange, gradient kind of stuff in our editor, right? So we're not expecting to get any glyphs, and I'm scared because it might say, yes, syntax error. Is the other shader still working? Okay, so the other shader is still working, but this is a syntax error. So we got to look and see what the syntax error is, and we can see in the log, implicit cast from int to bool. Well, first of all, holy crap, int to bool. Oh, it's this thing. So I like to do stuff like this, but we can't do that in this, because this is valid C99 code here, but it's not valid. It's not valid GLSL code. So if we want to do something like that, we can say 1 equals 1, right? So if 1 equals 1, that's okay. So let's give it another shot. Let's give it another shot and see if we've made that mistake somewhere else. But I guarantee that is one mistake. I don't know if we've made that mistake somewhere else in the code as well. But that's definitely a mistake. So let's go over here and see what happens. Syntax error. So what's the error now? Is it the same error? Undefined variable AAC Uifrags PAINT5D main. This looks like we might have a case issue. Oh, you know what it is? So let's go look for this for a second, right? So let's stop this. Let's Control C, stop the code. Control C, and let's go look for this undefined variable. So you notice that the C99 code didn't complain, but the GLSL code complained. So what's that all about? Well, that's about... First of all, let's go open the fragment shader. So PAINT5D default shaders, and here's the current iteration. And we notice, hey, fragment shader common code, cool. The Tau Depot fragment shader code. So this is kind of more generic fragment shader code, but it's like more specific than fragment common shader code is very generic, generalized, common fragment shader code, right? This is still kind of generalized fragment shader code, but it specifically knows about the Tau Depot system, right? Tau frag. Okay, so what are we missing? Well, let's look at our list of dependencies here. So let's clear this out for a second. So Tau frag is right here, cool. And then there's also fragcom. So fragcom is right here. And then we have something else. Uifrags, right? UI fragment shaders. And you'll notice that this comes right before the PAINT5D system. So this is the PAINT5D system, and this is the actual shader code for it. So we're going to try to always keep these two right next to each other. This is kind of gross, what we did here. We should have just kept them all under the same namespace, and I'm never going to do this ever again. But that's the way it is right now, so oh well. Technical debt. So, with that said, what are we missing? Well, we're missing include ... / and then not quite this, but something like Uifrags dot PAINT5D dot frag dot string dot underscore. Okay, something like that, I think. Well, no, the C99 compiler will catch this if this path doesn't exist, right? But we can go look for that. So, hey, look at that, uifrags.paint5d.frag.string. uifrags.paint5d.frag.string. Hey, that looks like what we're looking for. uifrags.paint5d.frag.string. Okay, yeah, cool. So now, there could be mistakes in this. There could be mistakes in this code that leads to some problems. So now we'll kind of look at that, and now we have, so now we got two problems, because now we have two pieces of shader code that we're going to have to look at and inspect for mistakes. So this could just be a pain. Okay, so let's take a look. Syntax error, and what mistake have we made now? Implicit cast from float to bool. Great. Uifrags PAINT5D main. Okay. Has no return statement. Okay. Ooh, okay, yeah, because this is a, so this shader here, right? We said if this is OpenGL, return frag color. No. Because we have to change what we're doing here, because this is not the same thing as our this is not a main entry point. It's not a top level function like it usually is. So this so this should be, so here's what we're going to do. We know what we called it in the other thing. We call it UI, so floatvec4, UIRect1 pixel color, right? That's what we called it, right? So instead of anywhere we're seeing frag color, first of all, let's nuke this. Anywhere where we see frag color, we got to be careful about it, right? So frag color here needs to be removed from here, because now it's the same no matter what, because it's no longer a top level variable that's declared somewhere else. It's declared here. Okay, so then over here we have this kind of thing where we're returning frag color. That's not what we want to do. So UR1 pixel, right? Make floatvec4, and then right here this return statement is now right, so this is C99 and GLSL in this case. Right, so this is not a return from main entry point. Right, in this specific case, unlike other shaders we have written. How about wrote? Make it shorter. Yeah, so we just want to kind of be a little bit, yeah, so there we go. Do you want to still keep this, or if this or that? So this could create a problem. Ooh, yeah, this no op is going to create a problem, right? So we see implicit cast from float to bool. Here's our cast from float to bool. It's right there. So this is in the wrong place. So to fix this, honestly, we just need to fix this as a commentary, because, well, are we already using this? We're already using it. We don't need the no op anyways, because we're already using it right there. So let's just get rid of it, right? Now, however, we still have this kind of problem, well, where we don't know what we're doing because we're looking at these macros, this conditional compilation, and we don't know what we're doing because so we might want to just label this better, right? So this right here is ndef. This is OpenGL. So this is C99 code, right? So C99 code, right? So this is C99 code. So maybe we just want to be kind of like ridiculous about it, right? And say we screwed up more than one time because we didn't know this was C99 code because the macros, it's kind of easy to miss with the ndef versus the if defined versus if not defined. So maybe we want to be a little heavy-handed here. 1, 2, 3, 4. 1, 2, 3, 4. And then over here, do the same kind of thing. And just say this is going to be GLSL code. And let's just do a double underscore here so that kind of lines up nicely. Okay. And okay. Okay, so that's a little bit better. This is the GLSL code. This is the C99 code. Here is this. This is declared already up here. This is user interface rect 1 pixel color. Pixel RGBA. Yeah, just call it pixel. And then, yeah, okay. So everything kind of here is indented away from the extreme absolute limit. We are 4 spaces away from the column limit because we're going to stringify this code. Okay, so this error right here, the float to bool cast, that was absolutely in our no-op that we just removed. Cool. So we solved another bug in the shader code, which is this sucks right now. This is very difficult to find because we literally have to kind of go through the code and say, okay, this is the specific error that's happening in this function somewhere, and we don't really know what line number it is, right? So this is kind of hackish, what we're doing here. But that's why, especially in this case, what we're doing right now, we want to add a little bit of code, compile, add a little bit of code, compile. And we kind of violated that earlier, and now we're going to end up paying for it for a while. Hey, look at that. Cool. So let's go P for pattern and load the pattern. And we can see that the user interface rectangle is of the defined width, and it is exactly the height of the viewport, and that's how I wanted it. So if we make this bigger, right, it's still the exact height, but its thickness is static, right? Now I don't remember calling it. So we'll have to fix some of that stuff, but we're getting closer. One of our asserts failed. We'll have to figure out why our asserts are failing. Because we kind of like sized the window too small and then our assert failed. So the first thing we want to do is remove the assert and give it a proper error function. Oh no, this is an error function. This is a proper error function here. We'll get to that. We'll fix that later. But the first thing we want to do is a get status. We want to add all this stuff, right? So get add dot, and what do we do, right? So there's like a ton of files touched, and if I just look at these files, I actually don't know what was done, right? So people say, oh, don't comment what you did, comment why you did it, right? Okay, well, you know what? When I'm looking at all this stuff, I have no clue what I did, right? I have to look through all the files and do some pretty serious detective work to remember what I did if I come back to this in a few days or a month or a year. So the commit message, as far as I'm concerned, should just be, it should be terse, it should be short, and it should be the most important thing that I want. If I get amnesia, will be the most important thing I want to know about what I've been doing, about what I just accomplished, right? So, git commits dash am PAINT5D user interface rectangle now renders. Something like that. And we might want to keep that shorter, so like we could take rectangle and we could just call it user interface rect. If we really want to, we could call it UI rect, right? For UI is a pretty common abbreviation, especially in tech. But this is short. I think this is short enough where I'm satisfied that it's not. I don't think that's too long. So let's go commit that. And then let's clear. Let's do a git status. And let's do a git push kanji coder master. So the project compiles. We see what we want to see. It's a good checkpoint. It's a good checkpoint to where we can. Let's go check it on GitHub really quick. And let's make sure that that commit message, is that commit message too long, right? We can actually look at that on GitHub and decide for ourselves. So that next time, you know, if it is too long, we'll try not to make that mistake next time, right? So here is the repo for this. And we see PAINT5D user interface rect now renders. Yeah, that's fine, right? So we see we added the build script, we added the main C11 file, we added some code in the library, we added some code in the documentation, right? We added a lot of stuff, right? So if we look in the library, we can find where that's coming from as well. So we can go here and actually I don't want to look at all this, but I guess now I am. Holy crappity craps. You know, it's like I'm just like pushing around rectangles. It's like, it's crazy. It's like, what does all this code do? It like pushes around rectangles. That's all it does. And here we are. Okay, so let's think about what the next thing to do is. The next thing to do is get those buttons in, right? So we have like, we have to figure out how to get some buttons. We have to figure out where the data for those buttons is going to be stored. Like, what's the order for the buttons? What's the order for the buttons? How do we know what button is being clicked when the cursor is over that user interface? A lot of different things. So let's look at our agenda for a second. So this is the agenda. So we notice that agenda number 28 is Uifrags data/functions get rudimentary UI working for PAINT5D system. We're still on the same task. Like, we've made some strides towards getting that agenda item finished, but it's not quite done yet. So, but now we know. So, I'm gonna take a break. I'm gonna stop the stream for now, and I'm going to just go eat the food that I've had cooking for 4 hours now. It's been cooking at like 200, so it's not like it's gonna, hopefully it's not gonna be like all dried out, but should be edible. So it shouldn't be burnt at 200, so I'm gonna do that now. So this was video number 183. It's Tuesday, and it is 10:08 a.m. So I will be back at a later date. Okay, so let's stop streaming. Out of here. I'll be back maybe in 1 or 2 hours.